Tonight, we return to the species that never stopped remembering. The last experiment that worked. This is Homo sapiens, the storyteller, the survivor, and the restless architect of meaning. 300,000 years ago, in the shifting plains of Africa, something changed in the rhythm of thought. Firelight no longer just warmed the body, it began to illuminate the mind. A new kind of memory took root, one that could imagine what wasn't there yet. They would outlast glaciers, deserts, and every other kind of human, not because they were the strongest, but because they could turn survival into story, and that story, somehow, became us. You're listening to Sleepless Homo, soft science and slow storytelling for sleepless minds. Here, we don't race through evolution. We drift through it, carefully, quietly, through fossils, fire, and thought itself. Now imagine standing somewhere on the ancient plains of North Africa. No cities, no language, no history. Just the wind across red earth, and the quiet pattern of a creature beginning to think in new ways. What if the first modern humans never realized they were new? They did not name themselves, or carve symbols, or wonder about the future. They simply lived, hunted, and raised their children beneath skies that have since changed 1,000 times. Yet in their bones, something had shifted, a subtle geometry of skull and thought that would ripple forward into everything we now call human. Around 300,000 years ago, in a place we now know as Jebel Irhoud in Morocco, a small group of hunters left behind fragments of themselves in the ashes of their hearths. Fossilized skulls, jaws, and tools would one day tell us what they could not. These were not strangers to us. Their faces, if you met them, might seem startlingly familiar. Brow ridges softening, skulls rounded, jaws less heavy. They were not quite us, but they were no longer the archaic humans that came before. When researchers re-examined those bones in the early 21st century, new dating methods, thermoluminescence from heated flints, revealed a shocking truth. They were older than anyone had imagined, nearly 300,000 years. That one discovery pushed the dawn of our species far deeper into time, shattering the idea of a single cradle of humanity. For most of the 20th century, textbooks told a simpler story, that modern humans arose in East Africa, perhaps in the Great Rift Valley, around 200,000 years ago. It was elegant, tidy, and easy to illustrate. But nature rarely follows straight lines. New fossils began appearing across the continent, at Omokibish in Ethiopia, at Florisbad in South Africa, at Herto in the Middle Awash. Their shapes didn't all match neatly. Some skulls were modern in the brain case but archaic in the face. Others were the reverse. Each was like a different prototype, an experiment still running. Slowly the evidence began to whisper a new idea, that our species was not born in one place, but assembled across Africa through a web of connected populations sharing genes, ideas and survival for hundreds of thousands of years. This is what scientists now call the Pan-African model. Instead of a single birthplace, it imagines a continent as a patchwork of semi-isolated human groups, meeting and mixing whenever climate allowed. Over long stretches of time, natural selection and gene flow sculpted a shared anatomy, a modern shape with local flavours. One population might refine a lighter skeleton suited for heat. Another might pass on a cranial architecture better for complex social life. Together they formed the mosaic that became Homo sapiens. It wasn't a revolution. It was an accumulation of small corrections, spread across thousands of generations. The Jebel Irhoud fossils are remarkable not only for their age, but for their geography. Morocco lies in the far northwest of Africa, thousands of kilometres from the traditional cradle sites in the east. Finding early Homo sapiens so far west suggested something profound. By 300,000 years ago, our species' reach already spanned most of the continent. They were living in diverse landscapes, savannas, coasts, mountains, deserts, each shaping them differently. Africa was less a birthplace and more an entire ecosystem of evolution, a dynamic laboratory the size of a continent. At Jebel Irhoud, stone tools lay scattered among the bones, small, carefully struck flakes known as the Middle Stone Age tradition. They tell a story of precision and patience. The people here use prepared cores to produce uniform blades, a sign of planning and standardization. It takes a kind of mental rehearsal to strike stone that way, to imagine the shape before it exists. That invisible act of foresight carved into flint may have been one of the earliest forms of imagination. The same technology appears in sites thousands of kilometers apart, suggesting that these early humans were not isolated. Ideas, or at least habits, were moving with them across rivers, mountains and dry plains. To reconstruct their world, scientists turned to paleoclimate data, oxygen isotopes from marine sediments, and dust cores from the Sahara. The results revealed that Africa then was a continent in flux. Wet phases turned deserts into grasslands, inviting movement. Dry phases fragmented populations into refuges. These shifting corridors forced adaptation, recombination, and reunion. Each climatic pulse reshuffled human diversity like a deck of cards, ensuring that no single group could dominate for long. If there was an Eden, it was a moving target, appearing and vanishing with the rains. We can't know what they thought, or whether they recognized themselves as something distinct, but their eyes looked out over the same sun that still rises on us. They watched storms gather. They knew fear and hunger. And somewhere within those shared sensations, the architecture of modern emotion was taking shape. The parts of the brain that process empathy, anticipation, and social awareness were already much like ours. The evidence is not just in anatomy, but in what they left behind. Repeated habitation layers, hearths reused over seasons, flint cores carried from distant outcrops. These choices reflect memory and return, a rhythm of life anchored in place. If one walked into their camp at dusk, one might see a small fire flickering against the stone, the smell of cooked meat in the air. Perhaps laughter, not words yet, but shared sound rising over the crackle. The children watching the elders strike sparks, the rhythm of survival rehearsed endlessly. In those moments, our species was learning what it meant to be more than clever apes. They were learning time, past, present, future, and the trust that others would be there tomorrow. It is tempting to ask when exactly Homo sapiens began. But beginnings in evolution are never sharp. They are gradients, like dawn. One lineage shades into another. Distinctions that seem clear to us were invisible to those living through them. The fossils from Jebel Irhoud don't show a sudden leap, but a slow blending of traits, faces becoming flatter, skulls expanding slightly, teeth shrinking. Each modification a step toward what would one day recognize itself in a mirror. In that sense, we did not arrive. We emerged. Even with our best dating methods, margins of error remain large. Each discovery rewrites what came before. The oldest Homo sapiens today might not hold the title tomorrow. Sites in Ethiopia, Kenya, or South Africa could still yield older finds, and genetics adds its own layer of complexity. DNA from living African populations reveals deep splits among ancestral lineages, some extending back 500,000 years. It suggests that what we call Homo sapiens may include the legacy of several ancient subgroups, now long vanished but woven into the same tapestry. Our ancestry, it seems, is not a straight line but a braided river. What makes Jebel Irhoud so moving is its ordinariness. These were not kings or visionaries. They were families hunting gazelles and tending fires in a shifting landscape. Yet from their quiet persistence came everything. The eventual painters of Lascaux, the engineers of cities, the thinkers watching galaxies. Their gift to us was not a tool or a language, but a set of possibilities encoded in bone, endurance, curiosity, imagination, the seeds of all future experiments in being human. When we study those fossils, we look for answers. But what they give us instead is perspective, that the traits we prize, creativity, cooperation, foresight, were not sudden inventions, but slow convergences of necessity and chance. That evolution's most remarkable product is not perfection, but flexibility. These people survived not by dominating their world, but by learning from it. And if we listen closely, the evidence humbles us, because it reminds us that we too are a work in progress. The species that awoke 300,000 years ago is still waking, still testing what consciousness can hold. We often speak of them as our ancestors, but perhaps they were simply earlier versions of us, humans trying to make sense of the same planet we still call home. Their bones have long cooled into stone, but their experiment continues each time we choose to adapt instead of collapse, to learn instead of repeat. The fossils do not answer why they changed, only that they did, and that against odds measured in ice and fire, something new survived. Somewhere in the dust of Jebel Irhoud, beneath layers of time, rests the beginning of recognition. A skull tilted slightly forward as if listening, perhaps to the wind, perhaps to the future, and that, so far as we know, is where the story of us truly begins. If this kind of deep time comforts you as much as it does me, consider subscribing or leaving a like. It helps other wandering sapiens find their way back through the dark, and tell me in the comments, when do you listen? While drifting to sleep, studying, or just wondering what it means to be human? There are timestamps below in case you close your eyes and want to return later. No rush. The story has waited 300,000 years already. Now, let's begin. Somewhere in the deep Pleistocene, on a cool African night, a small fire burns, and a few upright apes begin to imagine everything that would follow. And as always, stay curious, stay calm. I'll see you in the next story. What if I told you that the story of humanity was never written in one place, but across an entire continent that kept rewriting itself? Africa was not just the birthplace of our species. It was the laboratory where evolution ran every experiment it could imagine, in bone, in brain, in behaviour. Across its endless mosaics of forest, grassland and desert, nature was mixing and remixing the same ingredients: isolation and reunion, drought and rain, extinction and renewal. For nearly 50,000 years after Homo sapiens first appeared, Africa was a moving stage on which the main test of being human was adaptability itself. Around 300,000 to 250,000 years ago, Africa was in constant motion, not in time, but in temperature. The planet's heartbeat, the glacial and interglacial rhythm known as marine isotope stages, was pulling climates back and forth like a tide. Northern deserts breathed green when monsoons pushed north, then turned back to bone-dry wastelands when ice returned to the poles. Lakes swelled and vanished. Rivers carved new routes, then died in silence. Forests migrated hundreds of kilometers in a lifetime. To live here was to live inside a planetary experiment, and the creatures within it, our ancestors, were learning the hardest lesson evolution ever gave: how to change fast without losing themselves. This instability, though cruel, created opportunity. When deserts opened into grasslands, human groups spread out, exploring, mingling and trading genes. When the rains stopped and regions dried, populations shrank back into refuges, river valleys, coastal plains, upland forests, where they were cut off for generations. These cycles of separation and reunion did not just shuffle our geography, they forged our genetic diversity. Each isolation allowed small changes to accumulate. Each reunion blended them back together into something new. Over thousands of such oscillations, Africa itself became an evolutionary engine, a continent fine-tuning intelligence, cooperation, and endurance through its climate. If one could look down from orbit during those ages, the continent would not appear as a single cradle, but as a constellation of habitats flickering on and off through time. In the south, near Florisbad, people lived among open grasslands and hunted antelope with advanced Middle Stone Age tools. In the east, the Rift Valley populations left traces near Omo and Herto, tall, long-limbed humans shaped by heat, their flints bearing the signature of practiced craftsmanship. In the west and centre, wetter forest sheltered smaller, isolated groups that sometimes disappeared from the record altogether. And far to the north, at Jebel Irhoud, those same modern bones rested under what had once been a cooler, greener Sahara. Genetics confirms what the stone suggested. Early Homo sapiens were never a single tight-knit population. Instead, they existed as interconnected networks, clusters of humans separated by terrain and time, yet occasionally crossing paths when the rains returned. Imagine Africa as a breathing organism, its arteries of life expanding and contracting with each shift in rainfall. Populations that had been isolated for thousands of years would meet again, exchange mates, share skills, and then scatter once more. It was a pattern of contact and distance that kept evolution flexible. This structure, often called population substructure, is one of the reasons modern African genomes hold more genetic diversity than the rest of the world combined. It's not that Africa is more complex, it's that humanity never stopped evolving there. The landscape was the tutor. The Sahara, often imagined as a wall, was sometimes a bridge. During wetter periods, a green Sahara appeared. Rivers, lakes and grasslands teeming with fish and game. Stone tools and fossilized hippos tell us that humans roamed freely through what is now an ocean of sand. Then, as the planet cooled, the desert returned, cutting those corridors apart and pushing populations into survival mode. In the highlands of Ethiopia, humans adapted to thinner air. On the coasts, they turned to shellfish and tidal resources. In the rainforests, they learned to navigate dense canopy ecosystems. Each biome sculpted a slightly different version of us. Paleoclimate science has made this story visible in surprising ways. Layers of dust buried in ocean cores off West Africa record every wet and dry pulse in exquisite detail. Scientists read them like tree rings of climate, matching them to genetic divergence dates. Around the time Homo sapiens emerged, these records show enormous swings in precipitation, violent transitions that would have fragmented habitats across the continent. The result wasn't chaos, but creativity. Environmental stress didn't just test survival, it tested innovation. And somehow the humans who lived through it did more than endure. They learned to predict it. Archaeologists now suspect that this volatility may have nurtured the first hints of behavioral flexibility, an ability to plan for change rather than react to it. In sites across southern and eastern Africa, stone tools reveal repeated shifts in technique, suggesting that people were experimenting constantly with different ways to shape, strike, and hunt. The Acheulean hand axes of older species were giving way to smaller, more versatile flake tools, lighter to carry, easier to replace, better for a nomadic life shaped by uncertainty. Evolution was selecting for foresight, but this wasn't a smooth curve of progress. Some regions advanced, others reverted. Cultural traditions flickered on and off, often rediscovered after disappearing for thousands of years. To an archaeologist's eye, this looks like inconsistency. To evolution, it's learning. The African record shows that our ancestors were already experimenting not just with tools, but with strategies for survival. They were testing social bonds, mobility patterns, diet breadths, and ecological tolerance. In other words, they were running small-scale trials of being human long before civilization demanded it. One of the most important aspects of this human laboratory was mixing, not just of genes, but of ideas. Wherever groups overlapped, innovation seems to have accelerated. A stone technology developed in the south might appear centuries later in the east, carried by trade or marriage networks. Pigments like ochre, once rare, begin showing up across distant sites at roughly the same times, suggesting that humans were observing and borrowing from one another even without long-distance communication. Africa was enormous, but its ideas were mobile. Somewhere in this networked world, our species' distinctive traits began to settle. The long, lean bodies of savanna hunters, the expanded frontal lobes for social coordination, the widening circle of empathy that allowed cooperation beyond kinship. Even our emotional range, curiosity, patience, regret, may have deepened here, shaped by constant adaptation. Evolution doesn't design emotions for beauty, it designs them for survival. To thrive in Africa's shifting mosaics, one had to imagine tomorrow. Yet for all our progress, the record humbles us. We still can't say exactly where the centre of Homo sapiens lay, because there may never have been one. The fossil and genetic evidence point instead to a pattern of regional continuity and overlap, like ripples on water that merge but never erase each other. The same genes that allowed early sapiens to survive drought in southern refuges may have later combined with northern variants adapted to cooler plains. The result was not uniformity, but resilience, a species designed to handle change itself. Even today, echoes of that ancient structure remain. The extraordinary diversity among modern African populations, in DNA, in languages, in physical traits, is a living fossil of our deep past. It tells us that the human experiment was not about making one perfect model, but about keeping variation alive. Evolution's greatest achievement wasn't stability, it was flexibility. Africa did not build Homo sapiens to stay the same. It built us to adapt, and perhaps that is why every experiment in being human began here. The continent's vastness ensured no single group could define success. Its shifting climates prevented complacency. Its barriers and bridges ensured constant reinvention. For nearly 50 millennia, Africa was a crucible where chance and necessity negotiated what it meant to think, to remember, to plan. By the time the climate stabilized again, Homo sapiens had already passed through countless versions of itself. We don't know how they understood their world. We can only guess. But each storm, each drought, each green season of renewal must have carried lessons that linger in us still. That survival is temporary, that change is inevitable, and that no landscape, no matter how harsh, lasts forever. The fossils can't speak, but the data hints at something profound, that humanity's defining trait is not our intelligence, but our adaptability. It is what made Africa our first teacher, and what allowed us, much later, to take those lessons elsewhere. So when we look back and ask why every experiment in being human started here, the answer may be simple. Because nowhere else on Earth forced evolution to test so many versions of what it means to endure. Africa was not just our origin, it was our rehearsal. Imagine this, a night 250,000 years ago, somewhere deep in the African interior. The world is dark, truly dark, in a way we can barely imagine now. No cities, no horizon lights, only stars stretching from one end of the world to the other. And in the middle of that black ocean of silence, one trembling glow, a fire. Around it, a few humans sit close enough to feel warmth, far enough to see their own shadows flicker across the dirt. For the first time in history, light no longer belongs only to the sun. What changed around a fire that data can still measure? It might sound like a poetic question, but the evidence is surprisingly literal. In the last few decades, archaeologists have learned to read the chemistry of ancient ash, the magnetic signature of burned soil, even the microscopic crystals formed when wood meets flame. At sites across Africa and the Levant, some nearly 250,000 years old, these clues tell us that humans were no longer simply scavenging natural fire. They were managing it, keeping it alive, transporting it, feeding it, and in doing so, they began to transform not only their diets, but their biology and their minds. The difference between fire found and fire kept is enormous. Lightning can ignite grass, but only intelligence can keep flame alive through wind and rain. Traces of hearths at places like the Kaptharin Formation in Kenya or the caves of South Africa's border region show repeated burning in the same spot, layer upon layer of charcoal and reddened earth. To a geologist, it's just sediment. To a paleoanthropologist, it's a record of memory. It means someone remembered where warmth lived and returned to it again and again. Cooking, perhaps the most radical consequence of fire, changed everything from our jaws to our genomes. When food is exposed to heat, its chemical bonds loosen. Starches gelatinize, proteins unfold, toxins break down. What was once hard to chew and slow to digest becomes soft and calorie-rich. Anthropologists estimate that cooking may have effectively doubled the usable energy from the same amount of raw food. That energy didn't go to waste. Over evolutionary time, it supported larger brains, smaller guts, and longer childhoods. The energy budget of thinking. The transition to controlled fire predates Homo sapiens, but by 250,000 years ago it had become a way of life. In our species, the flame was no longer an occasional visitor. It was part of the household, but fire did more than feed the body. It began to feed the mind. Once daylight ended, most creatures slept. Fire pushed back the boundary of night, creating what neuroscientists now call extended cognition. It gave humans extra waking hours to process, plan, and share. Even without language, the circle of firelight was a new kind of space, safe from predators, warm enough for conversation in gestures, rich with the sound of crackling wood and the faint hum of insects beyond the glow. Around those hearths, social bonds were forged in a rhythm we still follow today. The modern circadian clock, the way our hormones, alertness and temperature rise and fall across 24 hours, may have been sculpted by these ancient evenings. Studies of hunter-gatherer societies who live without artificial light reveal something fascinating. People naturally divide nighttime into phases. There's a period of wakefulness after dusk for talk, laughter, and quiet tasks, followed by sleep, and sometimes a second shorter waking before dawn. The fire remains central throughout. It regulates temperature, wards off insects, and synchronizes group behavior. Perhaps early Homo sapiens lived by a similar rhythm, a shared sleep-wake cycle anchored by flame. The residue of those nights is measurable even today. In the soil of ancient caves, scientists can detect biomarkers from wood smoke, polycyclic aromatic hydrocarbons, proof that burning was habitual, not accidental. Some sediments show alternating layers of ash and unburned silt, suggesting fires were built, cleaned, and rebuilt over generations. It's difficult to overstate how rare that is in prehistory. A controlled hearth implies planning, cooperation, and patience, the mental architecture of community. Fire also changed how humans perceive the world. The spectrum of light emitted by a flame is warm and narrow, rich in red and orange but poor in blue. When your eyes adapt to it, distant objects fade into darkness, while faces and gestures glow vividly. This optical intimacy may have reinforced empathy, making people more attentive to each other's expressions and moods. Under firelight, emotion became visible. Perhaps that was the first spark of the complex social awareness that defines our species. Another measurable change is in our biology. Genetic studies of metabolic enzymes suggest that humans have been adapted to cooked diets for hundreds of thousands of years. Some researchers propose that cooking reduced the selective pressure for massive teeth and jaws, freeing up skull space for the expansion of the brain case. Others point to gut microbiome evolution, the communities of bacteria within us that shifted to handle processed high-energy food. Even our sense of smell might have changed. Traces of olfactory genes show modifications linked to smoke exposure and cooked aromas. Evolution, in short, was reprogramming itself around the hearth. And while we can't measure emotions directly, neuroscience gives us reason to believe that fire affected cognition in subtler ways. The rhythmic flicker of flame produces what psychologists call low-frequency visual stimulation, something that calms the nervous system and synchronizes brain waves. Experiments with modern participants show reduced blood pressure and increased attention when watching fire, especially with sound. It may be that our brains are literally tuned for this experience because for so many generations it meant safety. Fire was both tool and trance. As fire extended the human day, it also extended human thought. In darkness, surrounded by warmth, the mind is freed from the immediate urgency of daylight tasks. Nighttime may have been when planning emerged, the anticipation of hunts, migrations, or resource collection. Cognitive archaeologists refer to this as delayed return thinking, the ability to act in the present for future payoff. It's the foundation of imagination, though still far from symbolic expression. Around African sites dated to this period, there's evidence of resource caching, stones or materials gathered and stored for later use. That too may trace its origin to those hours when flame allowed reflection without distraction. Every controlled fire left behind tiny witnesses, burnt bones, heat-cracked stones, charred seeds. When analysed under microscopes, these fragments reveal the temperatures reached and the fuels used. Some fires burned at moderate heat, ideal for cooking, while others reached intense bursts, perhaps used to harden wood or manage landscapes. In South Africa's Wonderwerk cave, for example, the gradual accumulation of fire residues suggests people were mastering not only how to light fires, but how to maintain them across seasons. By 250,000 years ago, the relationship between humans and flame had become symbiotic. One sustained the other. Even predators learned to keep their distance. The smell of smoke and human presence likely created invisible boundaries across the savannah. Fire expanded the night range of humans and shrank that of lions and hyenas. For the first time, our ancestors could stay awake safely after sunset. That shift in temporal niche, being active at night without fear, may have reshaped human evolution as profoundly as any tool. More time awake meant more opportunity for learning, bonding, and reproducing. A species that could thrive day and night was one that could outlast almost anything. Of course, not every group mastered fire at once. Archaeological evidence shows patchy adoption. Some populations maintained it continuously, others lost it during wet or resource-scarce periods. Controlling flame required constant vigilance. Wet wood, wind, or absence of spark stones could erase the skill for generations. Firekeeping was as fragile as knowledge itself. Perhaps that fragility taught early humans the importance of teaching and continuity. of handing down what they knew before it vanished into ash. We can never know the first person who stayed awake just to watch the embers fade, feeding the coals until dawn. But their decision, humble and repetitive as it was, marked a turning point. Fire turned survival into routine, and routine into culture. The hearth became a point of return, a primitive form of home long before walls existed. Every subsequent structure, from huts to temples, would echo that same circle of light. To study fire is to study time itself. Ash layers mark presence. Charcoal marks energy transformed. Magnetized minerals realign in heat, freezing the Earth's field in place, allowing scientists to measure not just that a fire burned, but from what direction the wind blew that day. Even in silence, data remembers the flicker. And yet, for all the science, something about those fires remains beyond measurement. What was it like to see colour at night for the first time, to watch sparks rise into a dark sky, and wonder if they were returning stars? We can't test that, only feel the echo of it when we stare into our own fires, campfires, or screens alike. Our fascination with flame hasn't faded because it's older than thought itself. When researchers sift through the layers of ancient caves, they're not only uncovering soot and bone, they're uncovering the shift from instinct to intention. The mastery of fire represents one of the few moments when evolution can be seen mid-step, a physical transition captured in carbon. Before fire, humans depended on the world as they found it. After fire, they began to shape it. It was the first real technology, and still the one we can't live without. So what changed around a fire that data can still measure? Almost everything. The chemistry of our food, the rhythm of our days, the architecture of our sleep, the network of our minds. Fire made the night a place we could enter instead of fear. It built a bridge between survival and reflection, between biology and culture. When you imagine those early people sitting beside a dim glow 250,000 years ago, you're not just picturing the past, you're looking at the beginning of our shared humanity. Every flicker of warmth we chase today, every light we kindle against darkness, is a memory of that first circle. The flame did not just change the night, it changed what it meant to be awake. What if I told you that the first human invention wasn't a tool or a fire, but memory itself? Not the kind of memory that simply recalls, but the kind that remembers how to make, how to fix, how to teach. Around 250,000 years ago, long before words were spoken, Homo sapiens learned to preserve information across time, not through writing or speech, but through bodies and imitation. In that quiet, pre-verbal world, every gesture was instruction, and every repeated movement was a kind of archive. Memory, once just a feature of brains, began to link across individuals. It became social. And from that point on, knowledge could outlive the knower. Archaeology gives us glimpses of this invisible revolution in the form of tools that no single mind could have invented alone. In the Middle Stone Age, across sites from southern to eastern Africa, we find hand-sized flakes and points that reveal a remarkable consistency of design. Shapes recur over hundreds of kilometres and tens of thousands of years. The Levallois technique, where a core is carefully prepared, then struck at just the right angle to produce a sharp, symmetrical flake, shows planning, geometry, and an internal model of cause and effect. But most importantly, it shows learning. A single discovery cannot explain that uniformity. It had to be taught, watched, copied, and refined across generations. When we look closely at these artifacts, we see something astonishing. They contain not only evidence of skill, but of standardization. That means two individuals who never met, separated by 100 generations, were still producing tools with near identical proportions. It's like finding the same musical rhythm echoing through time. This repetition implies a culture of instruction where elders demonstrated techniques and learners imitated them precisely enough for continuity. Neuroscience suggests that such transmission required new kinds of cognition, an advanced mirror neuron system capable of mapping observed actions onto one's own body, allowing imitation without language. Watching became remembering, and remembering became survival. To understand how powerful that shift was, consider what imitation actually demands. It is not mere mimicry. It requires distinguishing between the goal and the gesture, understanding why an action matters, not just copying its motion. That kind of abstraction hints at theory of mind, the ability to imagine another's intention. Around this time, brain size in Homo sapiens stabilized near its modern average of about 1,300 cubic centimeters, but the internal wiring was changing more profoundly. Neural regions supporting working memory and long-term procedural recall, the parietal and prefrontal networks were expanding their collaboration. Brains were becoming not just bigger but more integrated. The archaeological record preserves small but telling traces of this mental leap. At sites such as Kathupan in South Africa and Olorgesailie in Kenya, we find points that were once hafted onto wooden shafts with adhesive compounds, plant resins mixed with ochre powder and heated to bind stone to wood. That recipe cannot arise by accident. It requires sequential thinking, gathering raw materials, combining them under heat, adjusting consistency, and understanding that the product will serve a future purpose. It also implies shared memory. Someone had to teach someone else that too much heat weakens resin, that ochre makes it less brittle, that timing matters. In those mixtures of ash, pigment, and pitch, we find the oldest chemistry lessons in history. This is where memory truly becomes collaborative. No single human could remember all the steps of survival alone. By distributing knowledge across a group through observation, apprenticeship, and collective practice, Homo sapiens created a kind of cognitive network. Each brain stored a piece of the whole, and together they formed a communal intelligence. When one member died, the knowledge persisted in others. Over time, such redundancy became an evolutionary advantage. Populations that could preserve know-how despite loss were more resilient to environmental change. In a sense, culture began as the nervous system of the species. Pigment use adds another layer to this story. At sites like Twin Rivers in Zambia and Bomvu Ridge in Eswatini, ochre pieces with grinding marks appear as early as 250,000 years ago. Whether used for adhesives, hide processing, or skin protection, ochre signals a level of material experimentation, an awareness that substances could be transformed. But what makes it significant here is repetition. People kept returning to the same materials, in the same ways, over immense spans of time. That suggests tradition, and tradition, at its core, is structured memory. Neuroscientists studying procedural memory today note that it relies on different brain systems than declarative memory. You don't consciously recall how to tie a knot or strike a flint. Your hands remember for you. This form of embodied recall would have been central to early human life. A child watching an adult haft a spear didn't need to understand the chemistry. They just needed to feel the rhythm of the process, to internalize it through repetition. Each successful copy reinforced neural pathways in the basal ganglia and motor cortex, encoding skill as muscle memory. Long before writing or speech, our ancestors were already transferring data through motion. To an archaeologist, a line of similar stone points might look static, but in reality it represents a living chain of communication. Every artifact is a fossilized conversation between generations. The precision of these tools implies not only skill, but teaching. Teaching in turn implies patience, the willingness to let another try, fail, and try again. This emotional tolerance may have been as important to evolution as intelligence itself. Cooperation requires empathy. Instruction requires understanding frustration. In that sense, pedagogy might be one of the oldest social technologies we possess. Around this period, hearths also become more frequent at sites with evidence of tool-making. Firelight, already central for warmth and cooking, likely became a classroom. Studies of light levels show that flames provide just enough illumination for fine work at close range. The flicker could have extended productive hours into the evening, when stories of success and failure, spoken or gestured, reinforced group learning. Night may have become humanity's first school. Under firelight, memory could be rehearsed, not just stored. Cognitive scientists sometimes describe human evolution as the history of external memory systems, ways we store and retrieve information beyond the brain. Writing is the most obvious example, but the process began with imitation. Each time a toolmaker left behind a perfect point, they externalized thought in stone. Each apprentice who copied it read that thought back into their own hands. These artifacts are not just objects, they are memory devices. In them we glimpse the birth of cumulative culture, the ability to build on previous generations instead of starting from scratch. It's worth remembering how fragile that process must have been. Without language or symbols, continuity depended entirely on practice. If a population shrank or dispersed, an entire technique could vanish within a lifetime. Archaeological sequences often show exactly that. Sophisticated industries fading abruptly, replaced by simpler traditions. These are not signs of regression, but reminders of how easily knowledge can be lost when networks thin. Culture in its infancy was as mortal as its makers, and yet, somehow, enough of it survived. By 200,000 years ago, standardization was so widespread that archaeologists can recognize distinct regional tool cultures across Africa, each with its own preferred flake angles and hafting methods. This diversity shows that innovation was local, but the principles of teaching and memory were universal. Wherever Homo sapiens lived, they carried not just tools but a way of learning. Modern neuroscience gives us a framework for understanding how such memory networks functioned. Human brains are wired for social learning. Observation triggers the same neural circuits as action. When we see another person perform a task, our own motor neurons simulate it internally, allowing us to predict outcomes. Over millennia, this built an unspoken grammar of technique, a silent continuity that allowed culture to accumulate long before speech codified it. Pigments, adhesives, and precision flakes may seem small achievements, but together they mark the dawn of a new kind of inheritance. Genetic evolution was now accompanied by cultural evolution, changes transmitted not through DNA, but through demonstration. A successful innovation could spread through a population faster than any gene. Knowledge itself had become adaptive. We often think of memory as a property of individuals, but in this deep time it was a collective organ. Each human mind extended into others through observation and imitation, forming the first true networks of knowledge. The fact that we can still trace these behaviors in artifacts is astonishing. We are not just finding tools, we are finding patterns of thought fossilized in stone. And yet, humility remains necessary. We can't know exactly what they remembered, or how consciously they taught. We can only infer from the precision of the archaeological record that something powerful had changed. Learning was no longer an accident, it was a system. And that system allowed Homo sapiens to endure climates, terrains, and times that would have erased any species dependent solely on instinct. Perhaps that is what made our kind distinct. Not bigger brains, but shared ones. When one person struck flint, they carried the memory of hundreds of others in their hands. When they showed a child, the network expanded. Every repetition was both a survival act and a message to the future. Remember this. 200,000 years later, we still do. Imagine this. You wake to the sound of others stirring before dawn, the crack of wood in the fire, the low hum of breath and movement. Someone makes a soft call across the camp. Not yet a word, but a sound that means come here, or look out, or simply I'm here. Around 200,000 years ago, in the world of early Homo sapiens, sound itself was beginning to mean something. Air pushed from lungs, shaped by throat and tongue, was no longer just noise. It carried intention. It carried thought. When did sound become thought? It's one of the most difficult transitions in the entire story of evolution to trace, because voices don't fossilize. Yet the evidence scattered across anatomy, genetics, and comparative behavior suggests that by this period, the machinery of speech was nearly complete. The difference between a grunt and a word is only a few centimeters of anatomy and a few million years of practice. The first clue lies in a small horseshoe-shaped bone hidden deep in the throat, the hyoid. It anchors the muscles of the tongue, larynx and floor of the mouth, forming the base of the system that allows us to articulate vowels and consonants. Earlier hominins had simpler versions of this structure, but the one found in a Homo sapiens fossil from around this time, and even in some of their relatives, mirrors our own in both shape and placement. The positioning of the hyoid, combined with a descended larynx and expanded pharyngeal cavity, would have allowed a wide range of sounds. That anatomical shift marked the birth of potential speech. The hyoid story is subtle, but powerful. In species like chimpanzees, it sits higher in the throat, limiting the variety of sounds that can be produced. In humans, it drops lower, creating a longer vocal tract that can resonate vowels like A, E, and O. This change didn't come without risk. A lower larynx also increases the chance of choking. Nature rarely makes such a trade unless the payoff is enormous. In this case, it may have been the difference between a call and a concept, between reacting to danger and describing it. Anatomy alone, though, can't make meaning. Sound had to be coordinated by the brain. The regions that handle speech in us, Broca's area and Wernicke's area, were already identifiable in endocasts of Homo sapiens skulls from this era. Their asymmetry suggests specialization for sequencing, syntax, and auditory processing. Even if these early humans didn't yet use complex language, they were neurologically equipped for it. Neural circuits linking sound to memory, emotion, and motor control were growing tighter, allowing more precise control of breath, pitch, and rhythm. It's here that speech becomes as much a cognitive event as a physical one. The breath itself is a clue. Human speech depends on a long, controlled exhalation, a steady stream of air modulated by fine muscle adjustments. Other primates vocalize in short bursts tied to breathing cycles. They can scream or call, but not sustain structured sound. The ability to regulate airflow over long utterances may have evolved first for endurance running, another hallmark of Homo sapiens. The same muscular and neurological coordination that let us chase prey for hours may have later allowed us to speak sentences instead of cries. Evolution often reuses what works. The lungs that fed our stamina began to feed our thoughts. Genetics adds another thread to the story. The FOXP2 gene, often called the language gene, isn't unique to humans, but two key changes in its sequence appear to have been fixed in our lineage sometime before 200,000 years ago. These mutations altered how the gene regulated neural development in brain regions tied to vocal learning and fine motor control. When the gene is disrupted in modern humans, it leads to severe speech and grammar difficulties. In early Homo sapiens, its refined version may have improved the neural plasticity needed for speech acquisition. Yet FOXP2 alone didn't create language. It's part of a larger network involving dozens of genes that shape auditory memory, timing, and social cognition. What it represents is the shift toward learning vocal patterns, not just producing them. Songbirds show a similar mechanism. They must hear songs to reproduce them accurately. Perhaps early humans were undergoing a comparable transformation, moving from instinctive calls to learned vocal behaviours passed through generations. If that's true, then sound itself became a form of inheritance. Comparative evidence from other species reminds us how close the boundary can be. Great apes communicate using gestures, facial expressions, and a repertoire of calls that vary in context. Some experiments have shown they can invent new signals or modify old ones, but their control over breathing and vocalization remains limited. In us, the entire upper respiratory system became a precision instrument. Muscles from the diaphragm to the tongue could adjust in milliseconds. That level of coordination implies a brain attuned not just to sound, but to timing, the rhythm of meaning. Archaeologists can't hear those voices, but they can see their traces in behaviour. Around this time, coordination in hunting and tool-making reached levels that almost certainly required communication beyond mere calls. Cooperative ambushes, simultaneous spear throws, or group movements through dense terrain would demand signals with agreed meaning. Even simple proto-words, for now, go, stop, or fire, could have made enormous differences in success. The social complexity of early Homo sapiens, evident in their habitation sites, suggests that communication was already sophisticated, even if it lacked full grammar. The question scientists still wrestle with is whether language appeared suddenly or gradually. Some models propose a rapid cognitive leap, while others see a slow accumulation of vocal control, memory, and social feedback. The truth likely lies somewhere between. By 200,000 years ago, the pieces were in place. Anatomy capable of nuanced sound, brains capable of processing structure, and communities large enough to sustain convention. Meaning didn't arrive in a single moment. It condensed slowly out of noise. There's also evidence that the emotional palette of human sound was broadening. Voice is not just information, it's feeling. The ability to modulate tone, pitch, and rhythm would have deepened emotional communication, strengthening bonds between individuals. Neuroscientists studying mother-infant interaction note that melodic speech, what we now call motherese, triggers attention and learning. Perhaps the first proto-language grew not out of hunting strategy, but out of nurture. Soothing cries, playful imitation, rhythmic exchange. If so, the origins of speech are as much maternal as martial. Even the act of naming, of assigning sound to object, would have been transformative. Once a group could agree that a specific sound referred to something, they created a shared mental space. Sound became a bridge between minds. This capacity for symbolic association, still in its infancy at this time, was the seed of everything that followed: memory, teaching, cooperation, and eventually storytelling. But here, in these first murmurs, meaning was fragile, tied tightly to context and emotion. It was not yet language as we know it, but it was more than instinct. The fossil record adds one more layer of evidence in the shape of the ear. The bones of the middle ear in early Homo sapiens were tuned to the same frequency range as modern human speech, roughly 2 to 4 kilohertz. Earlier species had hearing optimized for lower frequencies typical of natural sounds or calls. This adaptation hints that our ancestors were beginning to live in a world where communication mattered enough to shape biology itself. The body was evolving to listen. We often imagine language as the defining feature of humanity, but perhaps it's better understood as a gradient, a series of overlapping systems of sound, gesture, and memory stretching far back into the past. By 150,000 years ago, Homo sapiens likely spoke in a proto-language, structured but limited, flexible but simple. It was a tool still being sharpened, but one already powerful enough to knit groups together across space and time. Every breath we take while speaking today is an echo of those early experiments. The airflow through our throats carries the same ancient rhythm. Inhale, control, release. When sound became thought, evolution crossed a threshold that would never close again. The human mouth became a doorway between mind and world, and yet, even with all our data, we can't say when the first word was spoken or what it meant. Perhaps it wasn't a noun or a command, but something softer, a sound of reassurance in the dark, a hum that meant I'm here. If that was the first voice to carry meaning, then the origins of speech were not in intellect, but in connection. So the next time you speak, remember that the air leaving your lungs has been practiced for hundreds of thousands of years. Every syllable carries the memory of those who first learned to shape breath into thought. And though we can never hear their voices, we live surrounded by their echoes, a planet still resonating with the sound of meaning itself being born. Imagine this: Africa, 180,000 years ago. The rains have stopped. The rivers that once carved through savannas lie dry and cracked. The wind carries dust instead of pollen. Herds that once migrated seasonally have vanished, replaced by silence and sand. In the long timeline of our species, this was the moment when intelligence itself was tested, not by predators, but by climate. Could a mind built for problem-solving survive a world that offered no solutions? Between roughly 190,000 and 130,000 years ago, Earth entered one of its most severe glacial periods, marine isotope stage 6. The ice sheets in the northern hemisphere expanded, locking up vast amounts of water. Global temperatures fell, sea levels dropped, and rainfall patterns shifted dramatically. For Africa, this didn't mean cold, it meant dryness. Across the continent, lakes shrank, forests withered, and deserts expanded until entire regions became uninhabitable. This was not a single drought, but a rolling catastrophe that lasted tens of thousands of years. For Homo sapiens, newly emerged and still fragile as a species, the effects were devastating. Genetic models and fossil evidence suggest that our population may have plummeted to a few thousand breeding individuals, perhaps fewer. The vast networks that once connected early humans across the continent fragmented into small, isolated enclaves. Anthropologists call these refugia, pockets of survivable land where food and water remained just stable enough to sustain life. The rest of Africa became, for a time, a graveyard of dry rivers and abandoned trails. The survival of our species depended on these scattered safe zones. One of the most studied lies along the southern coast of Africa, where shifting sea levels exposed rich marine shelves. Sites like Pinnacle Point and Claces River preserve evidence of human occupation through this climatic crisis. There, our ancestors may have turned to the ocean for salvation, harvesting shellfish, seaweed, and coastal plants when inland resources failed. It was a new kind of survival strategy, one that required foresight, patience, and adaptability. While most mammals fled or perished, humans learned to pivot. To reconstruct this era, scientists combine multiple lines of evidence: oxygen isotopes from ocean sediments, dust layers from marine cores, and climate simulations based on orbital changes in Earth's tilt and wobble. The data align in a sobering pattern. Africa during marine isotope stage 6 was the driest it had been in hundreds of thousands of years. The Sahara, the Kalahari, and the Horn of Africa all expanded simultaneously. Even the Great Lakes, Turkana, Malawi, and Victoria, shrank dramatically, in some cases disappearing entirely. What had once been a mosaic of connected habitats became a landscape of isolation. For a species like ours, dependent on cooperation and resource sharing, isolation was lethal. Populations trapped in different refugia would have lost contact, each evolving slightly apart in both genes and culture. Genetic evidence in modern humans still carries the signature of that bottleneck, reduced overall diversity compared to what would be expected from a larger, continuously connected population. It's as if our species barely scraped through a narrowing gate, emerging leaner, more uniform but still alive. Inside these refuges, survival must have demanded extraordinary ingenuity. Archaeological traces from coastal caves show advanced fire management, consistent tool manufacture, and seasonal resource planning, behaviours that imply long-term memory and social coordination. These were not mere scavengers eking out existence. They were organised survivors navigating environmental chaos. Perhaps these harsh years refined our intelligence through necessity. Every dry season was a test, every meal a product of calculation. The coastal hypothesis, proposed by researchers in the early 2000s, argues that reliance on marine ecosystems may have fundamentally shaped our species. Seafood is rich in omega-3 fatty acids and iodine, nutrients essential for brain development. If small bands of humans along the southern African coast turned increasingly to shellfish and marine life, they may have unintentionally fueled their own cognitive evolution. In a sense, starvation bred intelligence. The brain that could predict tides, remember safe coves, and track shellfish cycles had an edge. Farther inland, in the highlands and remaining wet corridors, other groups adapted differently. Some relied on underground plant storage organs, roots and tubers that could survive seasonal aridity. Others may have specialised in scavenging or hunting drought-resistant fauna. Diversity of strategy was key. There was no single African refuge, but a web of microhabitats where different solutions evolved in parallel. When climates later improved, these groups would reconnect, carrying with them a patchwork of survival knowledge. What makes this period so fascinating is how invisible it almost became. For decades, the fossil record seemed to show a mysterious gap between early Homo sapiens and the more familiar populations that reappear around 130,000 years ago. Many assumed a hiatus in occupation. But now we understand that absence as preservation bias. People didn't vanish. They moved into regions where archaeology rarely survives. Coastal shelves now underwater, caves later eroded by sea spray, valleys buried in sand. In those hidden refuges, the thread of humanity never broke. Demographic modelling based on genetic diversity paints a haunting picture of near extinction. One study estimates that effective population sizes may have fallen below 10,000 individuals, a number smaller than many modern cities. From that fragile base, all living humans descend. In evolutionary terms, it was the closest our lineage ever came to ending. Intelligence alone wasn't enough. Luck played its part. A shifting climate, perhaps a pulse of monsoons or the slow retreat of glaciers, reopened corridors between the refuges. Humanity began to reconnect, merging lineages that had been separate for tens of millennia. The scars of that time are still written in our DNA. Genetic bottlenecks reduce variation, and that reduced variation shaped everything from our susceptibility to disease to our shared physiology. It's possible that certain adaptive genes, those controlling stress response, skin pigmentation, or metabolic efficiency were fixed during this crisis. The humans who survived were not the strongest but the most flexible. Adaptability itself became a genetic inheritance. In paleo-environmental cores from the Southern Ocean, scientists have detected sudden increases in dust deposition corresponding to this dry period. That dust came from Africa, carried by winds sweeping over barren plains. Even at the scale of continents, the signal of our ancestors' hardship can be read. Beneath layers of ocean sediment lies a record of human endurance measured in microns of ash and sand. Perhaps what carried us through was not intellect in the abstract sense, but the kind of intelligence that notices patterns, the movement of clouds, the behaviour of animals, the rhythm of seasons. It was applied observation, passed down through generations of teachers and imitators. This kind of environmental literacy doesn't fossilise, but it might have been the most important survival tool of all. One can imagine the emotional landscape of that era, the fear of drought, the relief of rain, the decision to leave or stay. Each generation faced a world that seemed to change faster than they could understand, yet through that instability, cooperation persisted. The same empathy that once helped teach tool-making or coordinate hunts now became the glue that held groups together in scarcity. Sharing, compassion, and care were no longer moral choices, they were evolutionary imperatives. It is humbling to realise how close we came to disappearing, and how our survival may have hinged on such fragile acts. Passing on knowledge, maintaining fire, finding food in saltwater pools. Every future human story, from art to agriculture, depended on the endurance of a few thousand individuals who weathered this deep drought. In them, evolution learned that intelligence without resilience is not enough. By 130,000 years ago, the planet began to warm again. Glaciers melted, rainfall returned, and the deserts slowly retreated. Africa turned green once more. The surviving populations expanded from their refuges, reoccupying the continent, reuniting into a species that would soon explore beyond its home. But something within us had changed. Those long centuries of scarcity had carved a mental template, adaptability as instinct, cooperation as inheritance, memory as survival. The climate that nearly ended us had also defined us. When scientists analyse that narrow slice of time, between desperation and recovery, they're reminded of how evolution doesn't plan, it endures. Intelligence alone never guaranteed success. It was the humility to adjust, the awareness to learn, and the capacity to remember that saved us. We are, in the end, the descendants of those who learned how to live with uncertainty. And perhaps that is the real lesson of Marine Isotope Stage 6, that the mind of our species was not forged in comfort or abundance, but in drought, hunger, and perseverance. Every problem we solve today, every plan we make for tomorrow, carries echoes of that ancient resilience. When the world turned against us, we adapted, and in that adaptation humanity was truly born again. Imagine this, the edge of Africa, 120,000 years ago. The air is thick with salt and heat. Across the narrow strait, barely 30 kilometres away, another continent shimmers through the haze, Arabia, a mirage of sand and promise. Behind, the African homeland stretches vast and familiar. Ahead lies everything unknown. For countless generations, humans had moved within their continent's shifting borders, retreating and advancing with the climate. But now, for reasons we can only piece together, one group looked outward. What happens when a species leaves home for the last time? This moment, the first successful crossing out of Africa, was not an expedition of conquest or even curiosity. It was an act of survival shaped by opportunity. Earth's climate had begun to shift once again. The long aridity of marine isotope stage 6 was giving way to warmth and rain. Around 130,000 years ago, monsoon systems strengthened, greening vast parts of the Sahara and the Arabian Peninsula. Lakes filled, rivers flowed, and corridors of life opened where before there had been only desert. For a brief geological heartbeat, the world invited us to move. The geography of this migration was intimate and fragile. At its narrowest, the Bab el-Mandeb Strait, between present-day Djibouti and Yemen, may have been only 15 kilometres wide due to lower sea levels. To a small group of coastal foragers, it might have appeared as a visible shore just beyond reach. Whether they crossed on simple rafts, floating vegetation, or by island hopping through exposed reefs, the step was irreversible. The moment they set foot on the Arabian side, the human story became global. Archaeological traces of these early dispersals are subtle but growing. In southern Arabia, sites such as Jebel Faya, Aybut al-Awwal, and Dhofar contain stone tools almost indistinguishable from African Middle Stone Age technology. Levallois flakes, blade cores, and hand-sized points speak of a shared ancestry. Thermoluminescence dating places them within the window of these first migrations. These were not lost wanderers, but people carrying a tested toolkit, one that could adapt to multiple habitats. They were already generalists, capable of living along coasts, grasslands, and river valleys. Flexibility was their passport. Genetics adds another thread to this tapestry. Modern DNA lineages, particularly mitochondrial haplogroup L3, coalesce to an origin around this same time period. This suggests that a subset of African populations expanded outward, their descendants eventually giving rise to all non-African peoples. But the numbers were tiny. Estimates suggest only a few thousand individuals left Africa during these early waves, their survival depending entirely on ecological corridors that opened and closed like lungs with each climate oscillation. Humanity's global future rested on the rhythms of rainfall. The Arabian Peninsula they entered was not the endless desert it is today. For a few thousand years it bloomed with grasslands, freshwater lakes, and rivers teeming with life. Fossilized hippos, gazelles, and water birds found in ancient lake beds paint a picture of a green Arabia, a transient paradise between droughts. Humans could have moved through this landscape following the same herds they had tracked for millennia, carrying with them fire, tools, and social memory. It wasn't a dramatic march, but a slow seep, generations drifting northward through hospitable patches that gradually led toward the Levant, Iran, and beyond. To reconstruct these journeys, scientists have turned to paleoclimate data and computer modelling. Using satellite imagery, they have identified ancient river systems now buried under sand, some stretching hundreds of kilometres. These ghost rivers once connected Africa to the heart of Arabia, providing freshwater routes that may have guided human expansion. Genetic simulations suggest that populations moved in pulses corresponding to these wet phases. When the climate turned dry again, many groups likely perished or retreated southward, but some persisted, leaving faint signatures in both genes and geology. Archaeologists can trace their presence not through monumental ruins or art, but through the quiet language of stone. At Jubba in northern Saudi Arabia, tool assemblages show careful adaptation to changing environments, with facial points shaped for hunting open grasslands, smaller flakes for processing plants or hides. This versatility hints at minds that could improvise. Our ancestors had learned not to wait for stability, but to build resilience within chaos. This period marks one of evolution's most fascinating experiments, the intersection of climate opportunity and cognitive readiness. Homo sapiens had already mastered fire, complex tool-making, and social learning. What they now demonstrated was spatial imagination. the ability to conceptualize geography beyond the visible horizon. Crossing to a new continent required more than legs. It required the capacity to anticipate unseen landscapes, to imagine continuity of life where none had been tested. That is not instinct. That is planning. The journey northward through Arabia was not a single exodus, but a braided pattern of movement and retreat. Some populations pushed as far as the Levantine corridor, others followed coastal routes along the Red Sea and Persian Gulf. Sea levels fluctuated dramatically, sometimes revealing wide continental shelves, rich in shellfish and vegetation. These regions served as stepping stones, temporary refuges between droughts. Over thousands of years, this creeping expansion became a habit of our species, an evolutionary rhythm of dispersal. One of the most profound outcomes of this phase was genetic coalescence. While earlier populations within Africa had been fragmented, these migrating groups were small and mobile, mixing frequently as they moved. Over time, this reduced genetic diversity compared to their African relatives, a legacy still visible in human genomes today. It's a paradox. The further humans travelled, the more alike they became. Migration didn't just spread us, it unified us. What drove them forward? Part of the answer lies in ecology. As the global climate oscillated between wetter and drier phases, resource predictability decreased. Populations that moved had a better chance of finding stable conditions elsewhere. Curiosity, hunger, and necessity blurred together. Each generation may have ventured slightly farther than the last, following familiar species of antelope, following water, following memory. Some paths would have failed. Others would lead to new worlds. Survival favoured the restless. The archaeological record shows that by 70,000 years ago, Homo sapiens had established viable populations well beyond Africa's borders. The genetic threads leading to modern Eurasians, Australasians, and eventually Americans all trace back to this broad dispersal window. It was not a heroic adventure, but a quiet persistence. A migration written in footsteps and campfires, not in conquest. We can still see traces of that persistence in the material record. Burned hearths, flaked cores, and scattered bones lie buried under meters of desert sediment, waiting for the rare moment when a storm or dig uncovers them again. Each site adds a new fragment to a map that stretches from the Horn of Africa to the Indian subcontinent. Every discovery reveals how deeply intertwined climate and cognition were in shaping destiny. Perhaps the most striking aspect of this crossing is how ordinary it must have seemed to those who made it. They weren't setting out to colonize a world, they were simply following opportunity, as countless generations had done before. Yet from their small decisions grew the web of humanity that now spans the planet. The final exodus out of Africa wasn't planned, it was lived, one day at a time, through instinct, cooperation, and chance. This perspective humbles us. It reminds us that the moment which defined our species' global future was not a triumph of dominance, but of endurance. The crossing that changed everything was not marked by a single leader or invention, but by a pattern of resilience repeated across millennia. When Africa's boundaries shifted and its ecosystems breathed outward, humans were ready. Not because they sought destiny, but because they had learned to adapt to change itself. As the climate cooled again after 70,000 years ago, the green corridors of Arabia vanished. Deserts reclaimed the land, rivers dried, and coastlines receded. Most of the early migrants were cut off from their African roots forever, but they carried with them the tools, genes, and memories that would populate the world. Africa had given birth to intelligence. Now it had released it. Standing at that imaginary shoreline, one can almost feel the tension of the moment. Behind them lay the continent that made them. Ahead stretched a world that would test them in ways beyond comprehension. They could not have known that this crossing, one of many small steps, would eventually fill every continent with their descendants. And we, tens of thousands of generations later, are still walking outward, still looking for the next horizon. So what happens when one species leaves home for the last time? Everything changes. The planet becomes its inheritance, and the journey never ends. Humanity, once confined to a single landscape, became a force woven into all of them. The footprints at the edge of Africa mark not an escape but a beginning. The first steps of a species that learned to make the entire Earth its memory. Imagine this. You're walking along the edge of a forest somewhere in Eurasia, maybe 70,000 years ago. The air is colder than Africa's, heavy with the scent of pine and frost. You've been following the same herd for days, your family moving together through a landscape full of strange shapes and sounds. Then, across a clearing, you see movement. Not animal, not wind, but someone. A figure upright like you, walking with purpose, carrying a spear. Their face looks human, and yet not quite. The first meeting of minds that shared an ancestor hundreds of thousands of years ago has just happened, and neither side knows it. What did it feel like to meet another kind of human? Archaeology can't answer that directly, but the traces left behind suggest that between 80,000 and 50,000 years ago, Homo sapiens began to encounter others, relatives who had evolved outside Africa for hundreds of millennia. In the rocky valleys of the Levant, in the mountains of Central Asia, and along the coasts of Southeast Asia, the paths of distinct human species overlapped for the first time in deep time. These were not collisions of armies, but quiet, cautious crossings of lineages, biological dialogues rather than battles. The earliest meeting grounds were likely in the Levant, where the Mediterranean climate provided a rare refuge during glacial instability. At sites like Skul and Kafse in modern-day Israel, fossils of early Homo sapiens dating to roughly 100,000 years ago appear interlayered with those of Neanderthals in nearby caves such as Tabun and Kabara. The evidence suggests alternating occupation, one group moving in as the other retreated, perhaps following climate shifts or prey migrations. But these weren't isolated waves. Later, as conditions fluctuated again around 70,000 years ago, contact became sustained. Stone tools found across these overlapping regions reveal subtle convergences. Blade industries, hafted points, and fire-treated materials begin to appear in both populations, hinting not at imitation but at shared learning through proximity. This was not a single encounter but a slow blending along ecological frontiers. It is tempting to imagine the tension of recognition, the moment two species capable of reflection realized they were not alone. The genetic record tells us that these meetings were not just cultural, they were biological. Modern humans outside Africa carry small but consistent traces of DNA from other archaic humans. The percentages vary, but the story is clear. Interbreeding occurred multiple times, in multiple places. This wasn't an act of conquest or domination. It was contact, communication, and, in some sense, coexistence. When the genomes of modern people were first compared to those extracted from Neanderthal bones, the surprise was not that interbreeding had happened, but that it had left such a durable legacy. Scientists now see these exchanges as part of a larger process, a biological dialogue between lineages that had been separated for hundreds of thousands of years. Rather than one species replacing another overnight, evolution looks more like a web of interaction. Mating, sharing genes, sometimes absorbing, sometimes being absorbed. Every modern human carries within them a faint echo of these encounters, a molecular memory of the moment when the boundaries of us expanded. For the people who lived it, those boundaries would not have existed. To them, these others were simply unfamiliar bands of humans, strange, perhaps, but recognizably alive in the same way. The communication that began may have been silent, gesture, mimicry, shared firelight. Imagine a hunting party pausing at dusk, hearing another group's laughter across a ravine, the crack of distant wood, or the flicker of another flame. Curiosity and fear balanced in equal measure. The first diplomacy of our species may have been nothing more than tolerance. Archaeological layers across Eurasia support the idea of coexistence, not sudden replacement. In the Altai Mountains of Siberia, for instance, the Denisova cave preserves a record of habitation spanning over 200,000 years, with traces of both Neanderthals and modern humans occupying or visiting the same space at different times. DNA recovered from sediments reveals overlapping presence, footprints of entire populations sharing terrain. The Denisovans themselves, identified only by genetic data and a few bone fragments, were another branch of the human family. They too interbred with our ancestors, contributing genes still found today in populations from Melanesia to East Asia. What these genetic fragments reveal is not a history of clear separations, but of constant contact. When groups met, they exchanged more than tools and gestures. They exchanged adaptations. Some Neanderthal genes, for instance, influence immune response, helping modern humans survive in colder, pathogen-rich environments. Others may have affected skin pigmentation or fat metabolism, refining our bodies to new climates. Even if only a few encounters resulted in offspring, the advantages were enough to persist through time. It's a reminder that evolution doesn't always select for separation. Sometimes it favours integration. The encounters themselves likely varied. In some places they may have been fleeting, a brief meeting at a water source, followed by cautious avoidance. In others, they may have led to alliances, shared hunts, or even the merging of small groups. Population modelling shows that human density at the time was incredibly low, perhaps only a few thousand individuals across entire regions. In such sparse conditions, hostility would have been costly. Cooperation, even if temporary, could mean survival. We often imagine these meetings as moments of confrontation between modern and archaic humans. But that dichotomy is modern, not ancient. To those living then, the differences might have been subtle. A broader face, a heavier brow, a slightly different gait. The shared experiences of hunger, fire, and family would have outweighed any anatomical variation. They were all humans in a world still vast and unclaimed. Fossil evidence from regions like the Levant shows transitions so gradual that it's impossible to draw a clear line between before and after. Morphological traits blend smoothly across layers. Jaws, skulls, and tools merging like overlapping dialects of the same language. This continuity hints at long-term interaction. The world of 80,000 years ago wasn't divided into species territories. It was a fluid mosaic of peoples adapting to one another as much as to their environment. Genomic research continues to uncover how deep this blending went. Some modern African populations, though long thought to be genetically isolated, also carry traces of ancient introgression from unknown archaic humans, ghost lineages whose fossils we have yet to find. This means interbreeding was not a rare anomaly, but a recurring theme in human evolution. Every encounter contributed to the diversity that would later define us. It's easy to romanticize these meetings, to picture shared fires and exchange stories, but the reality was likely far more varied, a spectrum of interactions ranging from peaceful coexistence to violence. Not every contact ended in harmony, and not every hybrid child survived. Yet over time, the genetic and cultural threads wove together into something enduring. Humanity was no longer a single branch, but a network of branches that occasionally rejoined. The term species itself begins to blur here. Biologists define species as populations that do not interbreed successfully, yet the evidence shows repeated interbreeding among ancient humans. Perhaps it's more accurate to think of them as regional variations of a single, adaptable genus, each shaped by its environment, each capable of blending when conditions allowed. In that light, evolution looks less like a series of replacements and more like a braided river, with channels diverging and rejoining across time. For the first Homo sapiens venturing north, the encounter with these others must have been both mirror and revelation. To see another kind of human was to see themselves more clearly. Until then, they had no concept of difference beyond tribe or landscape. Meeting another lineage forced reflection. What does it mean to be human if there are others who are almost but not quite you? That question, unspoken and perhaps unfelt, may have been the first spark of self-awareness at a global scale. Today, our genomes carry the memory of those moments in chemical code. A few percentage points of Neanderthal DNA here, a trace of Denisovan ancestry there, whispers of unions that once bridged evolutionary divides. Each of us is a living record of contact, of connection, of the blurred lines that define our origin. We are literally the sum of all who met before us. The archaeological record remains incomplete, and every new discovery complicates rather than simplifies the story. But one truth emerges clearly. Humanity has never been singular. From the very beginning, our survival depended on exchange of genes, ideas, and cooperation. The first encounters didn't just shape who we are biologically. They set the pattern for how we would expand, adapt, and define ourselves in relation to others. We'll never know the exact moment two lineages reached out across the ancient cold and realized they were not alone. But in that gesture, whether born of fear, curiosity, or compassion, the future of our species was rewritten. The world stopped being empty, and humanity stopped being one. From that meeting onward, our evolution was no longer a story of isolation, but of contact. And perhaps that's what it means to be human, not to stand apart, but to mix, to merge, and to remember. Every time we look at another face and feel recognition, we're echoing that first meeting in the Paleolithic twilight, the moment when one kind of human looked into the eyes of another and saw, for the first time, something that felt like home. Imagine this. A single blade of stone, long and narrow, rests in the palm of a human hand 60,000 years ago. Its edge is sharp, its symmetry perfect. But it's more than a tool. It's a pattern, a memory, a story already told before the hand that holds it was born. Across thousands of kilometers, others are making the same blade in the same way, following invisible rules no one had to write down. Somewhere between the strike of stone and the spark of understanding, the human mind began to think not just of cutting, but of continuity. When does a blade become a sentence? Around 60,000 years ago, something subtle but extraordinary happened in the archaeological record. Tools stopped being only local improvisations and began to follow shared templates. The emergence of standardized blade industries, long thin flakes struck from carefully prepared cores, marks one of the great turning points in cognitive evolution. It wasn't the invention of stone itself, but of sequence, a structured, repeatable method passed through generations like grammar. Sites from Africa to the Levant, from South Asia to Europe, show evidence of this technological coherence. The blade cores of the Upper Paleolithic weren't just functional, they carried cultural signatures. Groups separated by mountains or seas still followed similar ratios of length to width, angles of percussion, and methods of striking. These proportions hint at shared mental blueprints, knowledge encoded not in genes, but in memory and imitation. A community that could teach the geometry of a blade could, in time, teach anything. The process of making one was itself a kind of choreography. First, the core had to be shaped into a precise convex form. Then the platform prepared and struck with calculated force to detach predictable flakes. Too little pressure, and the blade shattered. Too much, and it fractured unpredictably. Success required visualizing a shape that didn't yet exist, holding an imagined outcome in the mind, and summoning it through movement. That ability to project structure from imagination is in many ways language in another medium. When anthropologists describe these industries, such as the Howisson's port in Africa or the Orignacian in Europe, they see not just tools but the first evidence of syntax. Each step in the process builds on the previous one in a fixed order. There's an introduction, a body, and a conclusion. One action misaligned, and the narrative fails. The leap from chaotic flaking to structured napping mirrors, the leap from scattered thought to organized speech. The stones themselves record the rhythm of intention. This technological fluency spread hand in hand with other signs of symbolic cognition. Pigments ground into powders, perforated shells worn as ornaments, and eventually the earliest musical instruments. These were not separate inventions, but variations of the same underlying capacity: abstraction. To take ochre from earth and turn it into colour, to pierce a shell and hang it from the neck, to hollow a bone and make it sing, each required the same mental template of transformation. Matter had become message. Pigment use offers a particularly vivid glimpse into this transformation. In African sites such as Blombos Cave and Sibudu, layers of ochre processing kits, shells used as containers, grindstones and residues mixed with fat show that colour was deliberately created and curated. Ochre could waterproof hides, protect skin, or preserve meat, but its use in decorative contexts suggests a deeper purpose. It marked bodies, objects, and perhaps group identity. Red ochre, in particular, recurs so persistently in the record that it seems to carry meaning across continents. Colour itself had entered the human vocabulary. Meanwhile, in Europe and Western Asia, bone and ivory ornaments appear around the same horizon. Beads, pendants, and teeth strung on fibres are found in contexts suggesting personal display. To craft such small objects requires patience and planning. Drilling, polishing, threading. Each one takes hours. They served no utilitarian purpose but embodied the invisible: status, belonging, or memory. When worn, they communicated something wordless, a social identity recognized at a glance. Like language, ornament allowed information to travel faster than speech. Then came sound. The oldest known musical instruments, flutes carved from bird bones, appear around 40,000 years ago in the caves of southern Germany. Each has been carefully perforated with evenly spaced holes, tuned to produce scales recognizable even to modern ears. It's almost impossible to overstate what this means. Music, unlike tool-making, serves no immediate survival function. It coordinates emotion. It synchronizes groups. A community that could make music was one that could cooperate beyond necessity. Rhythm is memory externalized, the heartbeat of shared time. From blades to beads to flutes, we begin to see the same underlying phenomenon. Humans learning to share patterns. Each artifact is a sentence in the expanding grammar of culture. Standardized blades reflect collective thought about utility. Ornaments reflect shared understanding of value. Music reflects shared emotion. Together they form the earliest paragraphs of human imagination. Some researchers call this transition the emergence of behavioural modernity, but that phrase can feel misleading. There was no single revolution, no overnight transformation. The change unfolded slowly, unevenly, across regions. Some groups developed complex toolkits earlier, others later. What unites them is the gradual externalization of thought, the process by which ideas left the brain and entered the physical world. Tools were no longer just for survival, they were repositories of meaning. Consider the precision of these artifacts. A blade from one site can match one from another thousands of kilometers away with astonishing accuracy. This isn't coincidence, it's convention. To sustain that level of similarity, knowledge had to move through teaching, imitation, and communication. That implies not just language, but communities large enough to preserve linguistic stability. Words, gestures, and rituals must have surrounded these objects, each teaching the next generation not only how to make them, but why. Cognitive scientists see in this archaeological shift the evidence of recursive thought, the ability to embed ideas within ideas, like clauses in a sentence. A tool that requires multiple sub-goals. Shape core, prepare platform, detach flake, reflects hierarchical planning. It's the same mental architecture used to form complex grammar or narrative structure. When early humans mastered these recursive operations in stone, they were rehearsing the same logic that would later shape stories. The first storytellers were knappers, their stage the flint itself. And yet, for all the technical elegance of these industries, their emotional weight may have mattered just as much. The repetition of process, striking, grinding, polishing, bound individuals into communities of rhythm and purpose. Teaching someone to knap or to make pigment wasn't just transfer of skill. It was bonding, apprenticeship, and trust. Cultural memory is built as much through touch as through words. Archaeologists studying spatial distribution of artifacts note that these workshops were often communal. Areas of concentrated flake debris, pigment residues, and bone fragments indicate social learning hubs, places where many hands repeated the same gestures. Around these hearths, knowledge was kept alive through demonstration. Watching another's movement, hearing the sound of the strike, feeling the vibration through stone. These were the classrooms of deep time. Each successful replication strengthened the web of shared identity. If we step back and look at this period from afar, the world itself seems to quicken. Populations expand, technologies diversify, and exchange networks lengthen. Shells from distant coasts appear hundreds of kilometers inland. Pigments from one valley are found in another. These are not random scatterings. They signal contact and connection, evidence that humans were building social and symbolic landscapes that extended beyond the horizon. Even without art or writing, the material record of 60 to 40,000 years ago reads like a library. Each object is a phrase in a growing dialogue between humans and their world. To make something durable was to assert continuity, to leave a trace for others to see, to copy, to remember. For the first time, ideas could outlive their makers. That continuity, that transmission of thought through time, is what we now call culture. And perhaps this is where story truly begins, not in words, but in patterns shared and recognized. A blade shaped the same way in a faraway valley meant someone else thought like you did. A bead worn around the neck carried an echo of another's hands. A flute's melody connected breath to memory. Through these artifacts, humans began to experience themselves as part of something larger, a shared narrative unfolding across generations. When does a blade become a sentence? When it's made not just to cut, but to communicate. When its form follows not only function, but tradition, when a hand striking stone understands that others, long after, will know the same rhythm. The first stories weren't spoken, they were napped, strung, and played. They told of survival, connection, and belonging without a single word. By 40,000 years ago, humanity's mind had stepped fully into the realm of meaning. The world was no longer a collection of resources, but a field of symbols. Every tool hinted at an unseen thought, every pigment marked an identity, every sound invited memory. The boundary between matter and mind had blurred, and from that moment on, every human creation, from a stone blade to a symphony, would be part of the same ancient conversation. We'll never know the first melody, or the first person to grind ochre into red dust, or the first teacher to guide a student's hand over stone. But in every human act of making, the echo remains. The story began not with words, but with patterns, and it is still being told one creation at a time. Imagine this. Deep within a cave, a hand hovers above a stone wall lit only by the flicker of fire. The air smells of smoke, ochre, and damp earth. A human exhales, presses their palm against the cold surface, and blows pigment from their mouth, leaving behind not a hand, but its absence. It is 40,000 years ago, and for the first time someone records what is not there. They are painting the invisible. Why did humans begin to do this? Why, after hundreds of thousands of years of surviving with tools and fire and memory, did our ancestors suddenly feel compelled to fill the dark with images of things unseen? Bison in motion, horses that gallop across walls, lions with human eyes. Something had changed in the mind of our species, and it wasn't just skill. It was imagination, the ability to create reality twice, once in the world and once within. Between roughly 45,000 and 30,000 years ago, the archaeological record blooms with what scientists call the symbolic explosion. Across continents, from Europe to Southeast Asia to Africa, art appears almost simultaneously. It is not the birth of creativity that had been growing quietly for millennia, but its first grand performance. The human mind, already capable of language, memory and pattern, now turned inward. It began to represent, to reimagine, to dream. In France's Chauvet cave, paintings dated to around 36,000 years ago show horses, rhinos and lions drawn with astonishing grace. The artists used charcoal and ochre, shading and perspective, creating a sense of movement centuries before writing would ever exist. Torchlight revealed living scenes, herds in motion, predators poised to strike. Each stroke carried both observation and invention. No one had seen these animals exactly this way. They existed only in the shared space between perception and imagination. Far away, on the island of Sulawesi in Indonesia, another miracle of pigment and thought took form. Red hand stencils and depictions of wild pigs, dated to around 43,000 years ago, show that the impulse to represent was not local or cultural, it was species-wide. On different continents, separated by oceans and distance, humans began to think symbolically at the same time. This synchronicity suggests not coincidence, but a shared cognitive threshold reached independently, a point when the human brain became capable of sustained abstraction. But how? What neural shift could have sparked this flowering of imagination? Some researchers point to changes in the brain's prefrontal cortex, the region responsible for planning, memory integration, and creative synthesis. By this period, Homo sapiens already had the anatomical structures necessary for complex language. The emergence of recursive thought, the ability to embed one idea within another, allowed humans to think not only about the world but about their own thinking. From there, art may have been inevitable, an externalization of the inner world. Others emphasize the role of social complexity. As populations grew and groups interacted more frequently, new pressures emerged to communicate not just facts, but meaning, to mark identity, to tell stories, to bind communities through shared symbols. Art became both a mirror and a memory, a way of seeing oneself reflected in the collective. The handprints on cave walls might not have been signatures of individuals, but of belonging, the first human declarations of "we were here." Pigments themselves reveal the science behind these acts of imagination. Red and yellow ochres, manganese dioxide and charcoal were carefully selected, ground and mixed with animal fat or saliva to create lasting colour. In Blombos Cave in South Africa, ochre processing kits dating back more than 70,000 years show that this knowledge predated cave painting by tens of millennia. But only later did it transform from utility to vision. The same pigment once used for hide treatment and adhesives became a vehicle for imagery. Humans had begun to look at matter and see potential beyond function. Inside Chauvet, researchers have discovered evidence of deliberate lighting, torches placed strategically to animate figures with shadows, giving the illusion of motion. This was not art for art's sake. It was performance. The cave became both canvas and theatre. Those who entered were not simply painters. They were storytellers conjuring worlds that existed only in light and imagination. It's easy to picture an audience, perhaps children, perhaps elders, watching those flickering images, their minds filling the gaps between movement and stillness. In that trembling darkness, art and empathy were born together. The temporal pattern of this creativity is telling. For hundreds of thousands of years, human tools evolved slowly. Hand axes, scrapers, points. Then, within a few thousand years, entire symbolic systems appear. Art, ornamentation, music, and myth. It's not that intelligence suddenly increased. Rather, communication between minds became richer. A painting was not just a representation of an animal, but a shared idea that could be revisited, interpreted, expanded. The walls of caves became the first external memory devices, not for survival, but for meaning. Archaeologists studying Sulawesi and Blombos have noticed that these early paintings often depict animals with extraordinary attention to movement and anatomy. The artists were observers, scientists of the wild. They study musculature, motion and behaviour, but in many cases, animals are drawn not as they are, but as they feel, layered, overlapping and stylised. A rhino's horns are doubled to show charge and power. Horses merged together like a herd in motion. Representation here was not literal but psychological. Humans had begun to imagine time itself, compressing moments into a single visual rhythm. Neuroscientists now suggest that the ability to create such imagery required mental time travel, the capacity to recall the past and project the future. To paint an animal was to remember its form long after it was gone, to relive a hunt or anticipate one to come. In that sense, these images are fossilized thoughts, traces of memory preserved in stone. They're also evidence of imagination's survival value. By rehearsing experiences symbolically, humans could plan, teach, and adapt. Music, too, joined this explosion of imagination. Bone flutes discovered in German caves like Hohlfels, dated to around 40,000 years ago, show that melody accompanied image. Together, art and sound created emotional synchronization within groups. To make music is to feel time together. To make art is to see meaning together. Both serve to unify minds into something greater than any one brain: culture. The symbolic explosion also reveals something about how humans view themselves. Many of these artworks focus not on individuals but on animals, often rendered larger or more dynamic than life. The world was full of power beyond human control, and art became a way to engage with it, to understand, to honour, perhaps even to influence. The boundary between observation and reverence blurred. Art was both imitation and invocation. Even in Blombus Cave, far older than Chauvet or Sulawesi, engraved ochre pieces with cross-hatched patterns suggest the earlier steps toward abstraction. They carry no obvious meaning, yet their deliberate symmetry shows aesthetic intent. These geometric designs might have been exercises in representation, early attempts to organise thought visually. Over tens of millennia, that impulse grew into full-fledged narrative imagery. As imagination blossomed, so did connection. A painted wall was a conversation between minds across time. The person who created it spoke to those who would come later, long after the artist's voice was gone. In that sense, art was the first form of immortality. To depict something was to ensure it would not vanish completely. In a world governed by survival, this was a small defiance of impermanence, a refusal to let memory die. When we enter those caves today, torchlight dancing over ancient lines, we are not visitors but participants. Our eyes complete the same circuits of recognition that theirs once did. Neuroscientists studying brain imaging have found that observing art activates the same neural pathways as creating it, empathy across millennia. We still respond to the same contours of motion, the same rhythm of breath behind pigment. The connection remains unbroken. The birth of imagination didn't happen in one place or in one moment. It flickered to life wherever humans gathered in safety, shared stories, and looked beyond what was necessary. It was the mind's rebellion against limitation, the discovery that reality could be recreated. Once that threshold was crossed, it never closed again. From that point forward, the human world would be built twice, once from matter and once from meaning. Perhaps that's the real miracle. Art was not invented. It was remembered, the external trace of something the brain had long been rehearsing internally. Every generation since has carried that same compulsion to make visible what can't be touched. The handprints on cave walls, the painted herds, the flickering fires, they're our oldest language, the first proof that we'd begun to dream together. And if you listen closely in those ancient halls, beneath the echoes of dripping water and distant time, you can almost hear it. The quiet inhale before breath meets pigment, the first moment when a thought leaves the mind and becomes eternal. Imagine this. Somewhere in Ice Age Europe, a small group gathers in the pale glow of a winter sunrise. The air is still, the ground frozen. A shallow pit has been dug, lined carefully with stones and sprinkled with red ochre. In it lies a human, not discarded, but placed. Around the body others leave what they can spare. A necklace of shell beads, a carved bone point, perhaps a fragment of food. They linger in silence, each gesture deliberate, their eyes flicking between earth and sky. Then, together, they cover the form and mark the place. The act is not survival, it is remembrance. For the first time in human history, death has become a story. Between roughly 50,000 and 25,000 years ago, archaeologists begin to see burials that differ profoundly from anything before them. The evidence is quiet. Pigment, posture, tools, traces of care, but unmistakable. These are not mere disposals of corpses, they are acts of meaning. The living had begun to treat the dead as part of a continuing world, not as waste but as witness. It is here, in ochre-stained graves and the soft curve of ritual gesture, that humanity's awareness of continuity appears. Some of the earliest such burials belong to anatomically modern humans in places like Kafse and School in the Levant, but by the Upper Paleolithic the pattern spreads widely. The famous child from Lagar in Portugal, dated to around 24,000 years ago, was covered in red ochre and accompanied by ornaments, small deer teeth and shells, symbols that meant something to those who placed them there. At Sunghir in Russia, 2 children were buried head to head, their bodies lavishly adorned with over 10,000 ivory beads, fox teeth, and carved pendants. The time and care required to produce these grave goods is staggering. Each bead, shaped and polished by hand, represents hours of work, days of devotion for a life that had ended. Such investment makes sense only if death itself had acquired meaning beyond loss. The ochre found in so many of these burials is perhaps the most eloquent trace of that meaning. Long before its use in art, ochre carried symbolic weight. Red, the colour of blood, of life, of renewal. To cover the dead in red was not to mimic decay, but to imitate vitality, a gesture that seems to say, "You still belong." Some researchers propose that ochre was thought to aid a transition to another form of existence, or to mark the dead as sacred. Others think it was simply a way to resist the visual finality of death. Whatever its purpose, it speaks of emotion, of care, of reflection. At the site of Dolní Věstonice in modern-day Czechia, around 26,000 years ago, 3 bodies were interred together beneath mammoth bones and burned clay. 2 lie side by side, the third placed perpendicular across them. The arrangement appears intentional, possibly narrative, perhaps mythic. One skeleton shows signs of congenital deformity, leading some anthropologists to argue that this individual may have held a special place within the group's social imagination, a possible shaman, a figure both of this world and apart from it. Whether that interpretation is correct or not, the burial reflects an awareness of individuality. Each life had become a story worth framing in memory. What changed in the human mind to make this possible? For hundreds of thousands of years, our ancestors undoubtedly saw death. They watched it, smelled it, feared it. But at some point, seeing became understanding. Cognitive scientists describe this as theory of mind, the capacity to imagine the mental states of others. When applied to the dead, that ability creates paradox. The person you once knew is gone, yet remains present in memory. Burial, then, becomes a resolution to that paradox, a ritualized conversation between what is visible and what is imagined. At Sunghir and other Upper Paleolithic sites, the inclusion of grave goods like spears, jewellery and clothing points toward a concept of identity extending beyond the body. These were not practical gifts. The dead could not use them. They were symbols of self, of belonging to a group, of continuity across time. It's possible that such burials mark the emergence of ancestor concepts, not gods, not yet religion, but the first stirrings of lineage. By placing the dead in the earth with tokens of life, early humans began to create history. The act of burial also reshaped the living. It demanded cooperation, planning, and emotional expression. Archaeologists studying the spatial organization of Upper Paleolithic camps have noted that burials often occupy central or prominent locations, as though designed to remain visible in collective memory. Graves became anchors of landscape, physical reminders of continuity. Some were revisited or even reopened, suggesting ongoing relationships between the living and the dead. These practices blur the line between mourning and ritual maintenance, implying a social bond that endured long after biological death. What's striking is how global this behaviour becomes within a narrow window of time. From Africa to Europe to Siberia, burial rites appear almost simultaneously, though expressed differently. In Africa, sites like Border Cave and Taramsa show careful placements and pigment use. In Europe, elaborate ornamentation takes centre stage. In Siberia, mammoth bone structures enclose the dead in monumental gestures. This shared impulse suggests that the awareness of death and its transformation into story was not regional but species-wide. It marks the threshold between instinct and philosophy. We can only guess what these rituals meant emotionally. Perhaps they offered comfort, a way to cope with absence in a world without certainty. Or perhaps they were acts of teaching, demonstrating to children that death, though inevitable, could be faced with care. Whatever their motivation, they reveal a profound emotional intelligence. Burial is an act of empathy toward the dead, but also a way for the living to recognize themselves as temporary. It is, in a sense, the birth of humility. In the archaeological record, the earliest musical instruments and figurines often accompany these graves. Music and burial share something essential. Both transform emotion into structure. A melody, like a ritual, gives shape to what cannot be held. The same communities that buried their dead with beads and ochre also carved animals, flutes, and small human forms. To make art, to play music, to bury. These are all forms of remembering. They suggest that by the late Pleistocene, humans had discovered a way to keep the past alive through form. Even the physical positions of these burials carry meaning. Many bodies were placed on their sides, knees drawn up, the fetal posture. Whether intentional or not, it echoes birth, implying that death might have been seen not as ending but as return. Others were positioned facing east toward the rising sun, linking daily renewal to eternal cycles. Such symbolism hints that humans had begun to see themselves not merely as individuals, but as participants in a larger temporal pattern. Yet we must remain careful in our interpretation. It is easy to project modern beliefs backward. These burials might not have represented faith in an afterlife, but simply a recognition that life itself carried narrative, that relationships and memory mattered. The archaeological record cannot tell us what they believed. It can only show that they believed. And that belief, that the invisible could be made visible through ritual, is the beginning of culture as we know it. The earliest burials also illustrate something else, the emergence of beauty as consolation. At Sunghir, the aesthetic precision of the ivory beads suggests that grief was expressed through craft. Creating beauty for the dead may have allowed the living to manage pain, to transform emotion into pattern. In doing so, they invented not only ceremony but catharsis. Death became a story the living told to stay alive. When we look at these graves today, we see more than bones and pigments. We see a shift in perspective, humans looking back at themselves through time. Burial marks the moment we became aware that memory could outlast flesh. It's a moment that still defines us. Every monument, every memorial, every digital archive is a continuation of that same impulse, to make absence bearable through meaning. Somewhere in that ancient frost-covered clearing, as the group covers the last traces of their companion with ochre-stained soil, one person might have whispered something. A name, a sound, a thought. The wind carries it away. Millennia later, the soil still holds its colour. The pigment remains, the bones remain, the story remains. What once was grief has become archaeology. And perhaps that is what it means to be human, to stand beside the unknowable, to feel the pull of memory, and to make the silence speak. Imagine this. The Ice Age is loosening its grip. It is 25,000 years ago, and across Europe and Western Asia, the glaciers are still vast but receding. Valleys once crushed by ice begin to open like new pages, rivers return to their beds, and tundra grass gives way to patches of birch and pine. Here, in this fragile, changing world, humans begin to do something extraordinary. They start to build communities not just to survive, but to belong. For hundreds of thousands of years before this, survival was movement, following herds, tracking seasons, migrating when scarcity demanded it. But as the climate warmed toward the end of the last glacial maximum, groups of Homo sapiens began to settle more regularly in places where life could sustain itself. From the frozen plains of Moravia to the valleys of Ukraine and the open grasslands of Siberia, the landscape filled with what archaeologists now call megasites, vast seasonal camps of hundreds, sometimes thousands of people. They weren't villages in the modern sense, but they were something new. Societies built through cooperation, memory, and shared purpose. At Dolní Věstonice in the modern Czech Republic, a site dated to about 26,000 years ago, the remains of mammoth bone structures lie scattered across a slope overlooking a stream. Beneath layers of clay and ash, archaeologists have found hearths, kilns, tools, ornaments, and even fragments of fired clay figurines, the earliest ceramics in the world. These weren't pots for storage, they were symbolic or decorative, often shaped like animals or human forms. To create art from fire and earth meant something had shifted in how humans saw their environment. They were not merely surviving in it, they were shaping it. The people of Dolní Věstonice and similar sites lived within dense networks of cooperation. Mammoth bones and ivory provided both material and meaning. Circular huts built from tusks and hides were arranged around hearths, forming communities that endured through multiple generations. Food was shared, not just within families, but across the group. Some researchers believe that these societies operated on systems of reciprocal exchange, where generosity itself was a form of currency. When the hunt succeeded, meat was distributed widely, strengthening social bonds that would later prove crucial when seasons failed. This kind of cooperation required something more than instinct. It required social architecture. Anthropologists call it cooperative ecology, the human tendency to build survival not around dominance, but around coordination. Even today, remnants of this can be seen in hunter-gatherer groups whose success depends on communication, fairness, and memory. For Ice Age humans, cooperation was the best technology ever invented. It allowed larger groups to coexist peacefully, to specialize tasks, and to manage resources in ways that small, isolated bands never could. One of the remarkable things about the archaeological record from this period is the scale of organisation. At Magirich in Ukraine, 4 enormous dwellings made entirely of mammoth bones show evidence of construction planning. They were circular, roughly 6 meters wide, with entrances carefully aligned to prevailing winds. Fires burned at their centres, surrounded by storage pits and stone tools. It is hard not to see these as the first experiments in urban life, not in size, but in intent. Humans had begun to imagine permanence. During the harshest phases of the Ice Age, refuges like these became microcosms of stability. While the outside world was hostile, within the circles of bone and hide there was warmth, conversation, and learning. The archaeological traces tell stories of craft and complexity. Bone needles for sewing, beads of mammoth ivory, intricate carvings. These are signs of surplus time, of people no longer trapped in constant urgency. They had enough to survive, and so they began to create culture. At Dolní Věstonice, archaeologists discovered impressions of woven textiles baked into clay fragments, suggesting that humans were already weaving fibres into cloth long before farming began. Nearby, they found footprints of children preserved in ancient mud, frozen moments of play beside hearths. These details transform our image of the Ice Age from one of endless struggle to one of community and continuity. For every hunt and hardship there was laughter, teaching, and the slow rhythm of shared life. Climate played an enormous role in this transformation. As the last glacial maximum ended around 19,000 years ago, the planet warmed rapidly. Melting ice raised sea levels and redrew the map of continents. Vast areas of steppe vanished, replaced by forests. Game herds shifted, forcing human groups to adapt once more. But now they did so not by splitting apart, but by staying together. At sites across Eurasia, we see evidence of seasonal aggregation. Large gatherings where distant bands met to exchange materials, mates, and stories. Ivory from hundreds of kilometers away appears at single sites, suggesting complex trade and kinship networks that reached across regions. Humanity was knitting itself into a web of cooperation long before cities or agriculture. In the Middle East, especially in the Levant, similar patterns began to appear. Sites like Ohalo II, on the shores of the ancient Sea of Galilee, and dated to about 23,000 years ago, preserve wooden huts, grinding stones, and the charred remains of wild cereals. The people who lived there were still foragers, but they were experimenting with new forms of living, staying longer in one place, gathering and processing foods in bulk, reusing structures over generations. This sedentism before agriculture challenges the idea that farming created settlement. It may have been the other way around. Once humans learned how to live together in stable groups, food production simply followed. The success of these Ice Age societies lay in their ability to coordinate, to remember, and to plan. They invented what archaeologists sometimes call social storage, the capacity to depend on others for survival, rather than hoarding everything individually. This is visible even in burial sites of the period, where individuals buried with elaborate goods often belong to complex cooperative groups rather than ruling elites. Hierarchy, if it existed, was subtle, earned through skill, age, or reputation rather than imposed power. These early communities thrived not through conquest, but through connection. Fire remained at the heart of it all. Each hearth was both literal and symbolic, a nucleus of warmth and conversation, but also a point of continuity. In mammoth bone dwellings and open-air camps alike, circular arrangements of stones around hearths suggest communal gatherings. Charcoal layers show that fires were kept burning for long periods, perhaps through entire seasons. In the flickering light of those fires, humans exchanged not only food but ideas. They told stories, shared knowledge, and transmitted identity. The first social networks were not made of data, but of faces and flame. The cooperative world of 20,000 years ago was not idyllic, but it was resilient. When conditions worsened or game grew scarce, humans could rely on a network rather than a single camp. This distributed survival model, cooperation across distance, may explain why Homo sapiens endured where others vanished. The Neanderthals, though intelligent and capable, lived in smaller, more isolated groups. Modern humans, by contrast, were becoming an interconnected species, one capable of adapting through collaboration. The archaeological record also reveals hints of symbolic unity across vast territories. Venus figurines, small carvings of female forms, appear from France to Siberia during this period, differing in style but united in theme. They suggest shared ideas about fertility, continuity, and perhaps community itself. Whether these figures represented individuals, deities, or ideals is unknown, but their spread shows cultural conversation across immense distances. The world had begun to think collectively, By 15,000 years ago, as the Ice Age drew to a close, humans had mastered environments from tundra to forest, from savanna to shore. They constructed base camps, stored food, crafted durable shelters, and wove emotional and economic ties that spanned landscapes. In sites like Kostenki and Pavlov, we find not just tools but evidence of long-term planning, caches of raw materials, coordinated use of space, and shared resource zones. This is the archaeology of foresight, humanity's first experiment in society. And perhaps most remarkable of all, these early communities thrived without rigid hierarchies or formal institutions. Cooperation was their infrastructure. Memory was their architecture. The bonds between individuals, families, and groups became the scaffolding of survival. Each campfire was both a practical necessity and a symbolic centre, a place where the human experiment in community was tested, refined, and passed on. When we look back at Dolny Vestonets, Mezerich, or Ohalo, we are not seeing primitive shelters but the blueprints of civilization. These were the first spaces shaped by shared purpose, by the will to live together rather than apart. The Ice Age may have been cold, but it forged warmth between people, and that warmth proved stronger than any glacier. It is tempting to see these ancient camps as precursors to villages and cities, but perhaps it's more accurate to think of them as the first collective memories, places where the world's most enduring story began, that humans survive best not by standing alone, but by building together. And as the last ice retreated and green returned to the continents, those same fires still burned, not just for warmth, but for meaning. Around them, the world's first societies began to hum softly with the rhythm of cooperation, the quiet heartbeat of a species learning to become we. Imagine this. The last great hunt has ended. The reindeer herds have moved north with the melting ice, and the plains that once echoed with mammoth calls now shimmer with wild grain. The air is warmer, wetter, heavier with scent. A group of humans, our kind, sets down their tools beside a small river valley. Instead of following the animals, they stay. For the first time in human history, a season passes and they do not move. They do not yet know it, but this pause will change everything. Around 10,000 years ago, the great story of movement began to slow. Across the world, in the Levant, in the highlands of Anatolia, in the valleys of China and the forests of New Guinea, humanity entered a strange, quiet revolution. It wasn't sudden, and it wasn't planned. The world itself had shifted. The Ice Age was over. Glaciers retreated, sea levels rose, and the once hostile landscapes that had shaped our ancestors' endurance transformed into lush, stable ecosystems. In this new world, humans began to experiment with a radical idea. What if the wild could be persuaded to stay too? Archaeologists once imagined this as a single turning point, the invention of farming. But the evidence now suggests something subtler, an entanglement between humans and plants that unfolded over thousands of years. For generations, hunter-gatherers had already been tending wild cereals, burning fields to promote regrowth, and replanting useful seeds. The shift was not from ignorance to knowledge, but from mobility to memory. People learned not just to take from the land, but to anticipate it, to read its rhythms, and then rewrite them. In the Fertile Crescent, stretching across parts of modern-day Turkey, Syria, Iraq, and Iran, villages began to form near the edges of rivers and lakes. Sites like Jericho and Abu Huraira show signs of early permanence: stone foundations, storage pits, and grinding stones worn smooth by years of use. At Abu Huraira, archaeobotanical evidence reveals the slow domestication of rye and wheat. The grains grew denser, their husks tougher, and their seeds less likely to scatter. These weren't human inventions in the mechanical sense. They were evolutionary negotiations. As humans selected for certain traits, plants adapted to human rhythms. The world of nature and culture began to merge. But if this was progress, it came at a price. Sedentary life demanded stability, and stability required control. Food could no longer be left to the generosity of the seasons. It had to be managed, protected, stored. People built granaries to guard against famine and walls to guard against others. Diets narrowed, health declined, and diseases that thrive in dense populations, tuberculosis, smallpox, measles, found their first foothold. For the first time, humans lived close enough to livestock for pathogens to leap between species. The same goats and cattle that represented security also became the carriers of new vulnerabilities. Still, the benefits were undeniable. For the first time, community could feed more mouths than they could hunt. Children survived longer, populations grew, and with growth came diversity, of labour, of ideas, of hierarchy. The Neolithic village was more than a cluster of houses. It was a system. In sites like Sayonu and Hoyuk, archaeologists have found entire neighbourhoods arranged around shared courtyards and ovens. Walls plastered with lime and decorated with painted motifs suggest that life was no longer just survival. It was expression. People began to decorate the places they lived, to turn necessity into identity. In Çatalhöyük, dating to around 9,000 years ago, homes were built shoulder to shoulder with no streets between them. People entered through the roofs, moving across their village like ants across a hive. Inside, the dead were buried beneath the floors, binding generations together through shared space. Hearths burned in the same corners year after year, passing warmth from one life to the next. This was the beginning of domestic time, a rhythm measured not by migrations but by inheritance. Yet it's possible that humans didn't invent farming so much as surrender to it. Once we began to depend on harvests, the land's rhythm became our law. The crops had to be watered, weeded, and guarded. Hunting became supplemental, and freedom gave way to predictability. Anthropologist Jared Diamond once called agriculture the worst mistake in human history for its health costs and inequality. But perhaps that's too simple. It wasn't a mistake. It was an adaptation, a slow, irreversible compromise between autonomy and abundance. Climate again played its quiet hand. Around 11,000 years ago, the Younger Dryas cold snap abruptly ended, giving way to the stable Holocene epoch. This relative climatic calm created something humanity had never known before: reliability. Rivers found permanent courses, forests stabilized, and seasons became more predictable. The environment invited experimentation. Archaeologists studying phytoliths and pollen cores have traced this pattern across continents. Small human interventions accumulating until ecosystems themselves began to depend on us. The Anthropocene, in a sense, began in a handful of fields beside small fires. As food became predictable, so did relationships. Communities that once disbanded seasonally began to plan together, to store, to share, to argue, to remember. Kinship expanded beyond family lines to include neighbours, allies, and trading partners. The cooperative ecology forged in the Ice Age became the foundation for social complexity. Rituals developed around planting and harvest, aligning human time with cosmic cycles. The first calendars, marked in bone and stone, reflect this merging of natural and cultural rhythm. The sky became a clock, the soil a promise. At Göbekli Tepe in southeastern Turkey, built roughly 11,500 years ago, something astonishing took place. Long before domesticated plants dominated the landscape, humans gathered to build monumental stone enclosures filled with carved animals, snakes, vultures, lions, boars. These structures predate agriculture, yet required massive coordinated effort, suggesting that social organisation may have come before farming, not after. It's possible that the act of building these ritual spaces, feeding the workers, maintaining the gatherings, forced humans to stay in one place long enough to discover that the land could provide continuously. In other words, we may have built temples before we built farms, and those temples taught us how to farm. Everywhere this transition occurred, it followed a similar emotional arc. What had once been wilderness became landscape. What had been chance became pattern. The wild goats that once roamed free began to linger near settlements, drawn by grain and safety. Humans noticed, and instead of chasing them, they waited. Domestication was not conquest. It was a quiet mutualism. Wolves became dogs, wheat became grain, humans became farmers. Each species reshaped the others, but staying changed the human mind as well. For nomads, memory was geographic, traced across rivers and mountains. For villagers, memory became architectural, rooted in hearths, walls and graves. The landscape of belonging shifted from horizon to home. Permanence gave rise to ownership, and ownership gave rise to inequality. Some had more land, more grain, more tools. Others depended on their surplus. In those first small storage pits, the seeds of both civilization and division were sown. Still, it's hard not to feel awe at what emerged. Villages grew into networks. Networks became traditions. People developed pottery for cooking and storage, plaster for walls and weaving for clothing. The soundscape of the world changed. The grinding of stone, the crackle of ovens, the low murmur of human voices staying in one place long enough to shape identity. When we imagine those early Neolithic mornings, the smoke rising from hearths, the dew on young barley, the smell of damp clay, we're seeing the dawn of a new kind of time. Days were no longer measured by migration, but by maintenance. History itself began here, not with kings or writing, but with continuity, with a choice to wake up in the same place tomorrow. And yet, something was lost. The freedom to wander became the obligation to tend. The open plains gave way to fences, the sky to walls. The first cities thousands of years later would rise from this foundation of rootedness. But on that first day when a human looked at a field of wild grain and decided to stay, they couldn't have known what they were beginning, or what they were ending. Perhaps farming wasn't invention or surrender. Perhaps it was both, the moment we traded the adventure of survival for the architecture of stability. And as the earth warmed and the seasons turned, we built not just homes and harvests, but the very concept of tomorrow. Imagine this. A hand presses a reed stylus into wet clay. Each mark is small, almost careless. A triangle here, a wedge there. But together they form something that will outlive the hand that made it. The clay hardens in the sun, the words dry into permanence, and suddenly memory no longer depends on breath or bone. It is around 5,000 years ago, and somewhere between the Tigris and Euphrates rivers, the world's first archives are forming, not of stone or DNA, but of thought. Writing began not as poetry, but as accounting. In ancient Mesopotamia, farmers, merchants, and temple officials needed to track grain, labour, and trade. The first written marks, cuneiform, were born from the same human impulse that once tracked footprints in the mud or tallied shells by a fire. Clay tokens, once stored in sealed envelopes to represent goods, were gradually pressed flat and marked directly. A shift occurred from physical counters to abstract signs. Each symbol captured not just an object but an idea. 5 sheep, 1 jar of oil, 10 measures of barley. Memory, which had always lived inside the human skull, had just found a new home outside it. Archaeologists call this the cognitive leap, but it might be more accurate to call it a relocation. Writing externalized thought, turning the landscape itself into an extension of the brain. Before writing, knowledge was passed through voice and ritual, remembered by specialists, elders, shamans, storytellers. But spoken memory is fragile. It dies with the teller. Clay, on the other hand, endures. Once baked, it outlasts dynasties. The first known writer we can name lived in Sumer around 4,300 years ago. Her name was Enheduanna, a priestess of the moon god Nana, and she signed her hymns in cuneiform. To carve your name into clay was to declare that your voice deserved to echo. With her, writing became more than record. It became identity. She wrote, "My king, something has been created that no one has created before." She could not have known how literal that would become. From Sumer to Egypt, from the Indus Valley to the Yellow River, systems of writing blossomed independently, each solving the same problem in its own way: how to make thought permanent. Egyptian hieroglyphs danced with pictorial elegance, marrying art to administration. The Indus script, still undeciphered, whispers of an entire civilization's lost syntax. In China, oracle bones bear questions to ancestors. Cracks in the surface read as divine responses. The earliest state-sponsored dialogue between humanity and the unknown. But writing didn't just record memory. It began to create new kinds of memory. Cognitive scientists argue that literacy reorganized the human brain. The very act of reading, converting marks into sound and meaning, rewired circuits for pattern recognition, abstraction, and time. Oral cultures think in cycles, repetition, and rhythm. Literate ones think in lists, categories, and causation. Once information could be stored outside the body, the brain could specialize. Less memorizing, more imagining. This transformation rippled through everything humans touched. Law codes, like Hammurabi's, turned spoken judgment into fixed rule. The calendar and the ledger replaced the shaman's intuition. The invention of writing didn't just preserve truth, it created bureaucracy. And with bureaucracy came civilization's first paradox, that the tools we make to remember can also make us forget. The more we stored externally, the less we carried internally. Still, the clay tablets held power. They became the bedrock of continuity, a system that allowed empires to rise on inherited knowledge rather than chance. When scribes pressed wedges into clay, they were programming the first memory machines. Each sign was a data packet, each tablet a node in an expanding network of administration, trade, and culture. Tens of thousands of such tablets survive, carrying the minutiae of ancient life, beer rations, taxes, prayers, each one an unbroken thought across millennia. Then came papyrus in Egypt, parchment in Greece, and finally paper from China. Every new medium accelerated memory. Clay required labour, papyrus invited flow. Ink replaced incision, and thought became faster, more intimate. The human hand evolved from carving permanence to sketching ideas. Writing, once a sacred privilege, became an everyday act, a revolution in silence. With these new materials came a new kind of immortality. Reproduction. Copying became the core of survival. Scribes preserved myths and mathematics alike, linking generations through fragile threads of ink. Libraries rose, vast repositories of collective consciousness. The Library of Alexandria was not just a building, it was the first attempt to map the entire human mind. Its destruction still haunts us, a reminder that memory, even externalized, remains mortal. Writing's next metamorphosis arrived with Gutenberg's press around 570 years ago. For the first time, memory could multiply exponentially. The printed page democratized permanence, freeing knowledge from monasteries and palaces. Ideas could now migrate faster than armies. Literacy spread, and with it came the concept of universal memory, the belief that knowledge belonged to everyone. Humanity, once dependent on oral wisdom or priestly archives, now began to think of itself as a single, reading species. But this expansion also changed the tempo of thought. Oral traditions move at the pace of breath. Print moves at the pace of machines. The rhythms of memory quickened. Historians began to note the first symptoms of informational overload, the fear that too much could be recorded, that the world was drowning in its own recollections. Yet even that anxiety was ancient. The earliest Sumerian tablets include laments that scribes could no longer remember everything they'd written. Every age, it seems, believes it is losing its memory, when in truth it is just changing where memory lives. The evolution from clay to code follows a single logic: to externalize and expand the capacity of the human mind. Clay tablets were slow and heavy, but they outlasted empires. The printed page was fast and fragile, yet capable of infinite copies. The digital screen is lighter still, but ephemeral, more light than matter. Each step moves memory farther from the body and closer to abstraction. And yet, all of it, every inscription, every symbol, originates from the same impulse as those first wedge marks pressed into mud, the refusal to let time erase us. Anthropologists sometimes call writing a distributed cognition system, an external brain made of material and meaning. When a modern human consults a book or a database, they are not merely retrieving information, they are participating in a collective form of thinking that spans millennia. The clay tablet, the papyrus scroll, the printed codex, and the digital file are all neurons in the same planetary mind. But what did this do to our sense of self? Once words could outlive the body, mortality itself changed. To be remembered was to persist. The first kings and poets carved their names not for vanity, but for continuity, the illusion of presence across absence. The Epic of Gilgamesh, written on clay around 4,000 years ago, mourns exactly this: a man's struggle to accept death in a world where words can live forever. He who saw the deep, it begins, and indeed through those words he still does. The invention of writing also marked the birth of history. Before it, time was cyclical: seasons, migrations, returns. After it, time acquired direction. It became possible to compare, to chronicle, to imagine progress. The past could now be revisited, the future projected. Every civilization since has built itself on this linear memory, this illusion that permanence can be constructed one symbol at a time. Today, when we read an ancient tablet or scroll, we're not simply observing history. We're inside its machinery. Each letter, each stroke, is a thread in a long, continuous experiment in immortality. Writing made humans the first species capable of transmitting knowledge across thousands of generations without genetic inheritance. We became not just animals that remember, but animals that store. And that storage has transformed into culture, identity, and consciousness itself. Writing allowed empathy to cross time. It let us speak to people we would never meet, in centuries we would never see. It gave us access to minds long gone, minds that now live inside us as words. In this sense, every human alive today carries the echo of those first marks in clay. So perhaps immortality was never about living forever, but about being readable. A mark in clay, a line of ink, a digital trace. Each is a fragment of a species still trying to be remembered. Writing was not just the invention of communication. It was the beginning of permanence, of civilization's memory engine still running quietly beneath everything we do. And maybe that's the most human truth of all. We write not to escape forgetting, but to share it, to divide the burden of memory among countless minds, so that no single one of us has to hold the whole story alone. Imagine this. You stand in a world where every sound, every tool, every face belongs to one species, your own. The forests no longer echo with the calls of other humans. The plains no longer hold rival footprints. The last Neanderthal has fallen silent. The Denisovans have vanished into your genes. The small island species, the Floresienses, the Luzonensis, are long gone. You are alone. For the first time in 4 million years, there is only one kind of human left on Earth, and that, strangely, is not a triumph. When scientists look at the DNA of modern Homo sapiens, they see something paradoxical. We are astonishingly uniform. Compared to other mammals, even other primates, our genetic variation is tiny. 2 humans from opposite ends of the planet are, on average, more similar to each other than 2 chimpanzees from the same forest. The entire human species today carries less genetic diversity than a single troop of wild bonobos. In evolutionary terms, we are a single fragile experiment that happened to survive. This uniformity is a clue to our history, the imprint of bottlenecks, migrations and extinctions. Somewhere along the line, perhaps 70,000 years ago, our ancestors nearly vanished. The reasons are still debated: volcanic winter, climate collapse, or simply chance. Whatever it was, only a few thousand individuals may have carried our lineage through that narrow gate. Every living person today is a descendant of that tiny population. The rest, the other branches of the genus Homo, disappeared, leaving us as the last storytellers standing. For most of history, our success looked like expansion. We spread into every climate, every ecosystem, every niche that life would tolerate. We learned to control fire, stone, seed, and metal. But what began as adaptation became dominance, and what once looked like diversity, languages, cultures, ecosystems, is beginning to collapse towards sameness again. The planet that shaped us is now being reshaped by us, often faster than we can understand. This is the hidden cost of being the last. Survival without rivals does not mean stability. It means feedback without balance. For millions of years, evolution was a dialogue between species, competition, cooperation, replacement. Now that dialogue has become a monologue. Every predator, every habitat, every climate system interacts with one apex participant, us. We have become not a species among many, but a force across all. In the genetic record, you can see the silence of our lost kin, the Neanderthal sequences within us, fragments of a vanished people, remind us that survival was never pure. It was hybrid, entangled, messy. Our story is not one of replacement, but of absorption. We carry the ghosts of others within ourselves, and yet, on the surface, we've forgotten them. The irony of success is that we became the sum of many humans and then imagined ourselves as one. Culturally, the same pattern repeats. Thousands of languages once shaped the world's soundscape, each one a separate model of reality, a unique experiment in thought. Now, most are dying. Every 2 weeks, one goes silent forever. The diversity that once mirrored our biological mosaic is thinning. These songs, myths, and ways of seeing that carried our species through deep time are collapsing into a few global narratives. What began as connection has become convergence. We have built a civilization so vast that it has begun to erase its own variety. The Earth's surface tells a similar story. The Anthropocene, a proposed new epoch defined by human impact, is a geological record of dominance. Layers of plastic, concrete and carbon form a thin artificial stratum that will one day mark our presence to whatever mind may study it. Forests are fewer, rivers run straightened and dammed, oceans carry our chemistry. Half the planet's habitable land now serves a single species' appetite. What evolution produced in tens of millions of years, we've reorganized in a few centuries. It's tempting to call this progress, but even progress carries entropy. Our power is not infinite. It is borrowed from the soil, from the oceans, from the steady climate of the Holocene that made civilization possible. That climate, once stable for 10,000 years, is now in flux again, this time because of us. We have transformed survival into success, and success into risk. Yet there's something quietly humbling in this realization. For all our control, we remain biologically fragile. Our genetic sameness, the very mark of our unity, also makes us vulnerable. A single pathogen, a shift in temperature, a collapse in the systems we depend on, all ripple through our species with frightening efficiency. In evolutionary terms, we have placed all our bets on one branch of the tree, and though it has carried us far, no branch can grow forever. Still, the story isn't only one of loss or danger, it's also one of unprecedented connection. For the first time, every human can, in principle, speak to every other. Knowledge that once vanished with a storyteller now persists indefinitely. Ideas travel faster than genes and sometimes more powerfully. This global network, our shared nervous system, is both our strength and our test. Never before has one species been so aware of its own scale. Perhaps that awareness itself is the final stage of our evolution, not biological but cognitive. We have become a self-observing species, able to study our own patterns, to recognize our own fragility. The same brain that carved stone tools now models the atmosphere, sequences genomes, and questions its own survival. We are both the cause and the chronicler of the age we live in. When paleoanthropologists look back at the fossil record, they often describe evolution as a series of experiments. Homo habilis, the maker, Homo erectus, the traveller, Homo neanderthalensis, the thinker, and us, Homo sapiens, the survivor. But perhaps that title is misleading. Survival implies endurance, but endurance can take many forms. The Neanderthals survived in us. The Denisovan survived in our genes. Even extinction can echo through time as influence. If we measure success only by persistence, then perhaps we misunderstand what the experiment was for. For 4 million years, humanity was never alone. We lived alongside cousins, rivals, shadows of what we were and what we could become. Their disappearance gave us the illusion of victory, but also the burden of memory. To be the last is to inherit not just the earth, but the silence left behind. Every fossil, every forgotten genome is a reminder that intelligence alone does not guarantee permanence. And yet, here we are, the last experiment that worked. The species that learned to outlast every storm except the ones it creates. Our story is a chain of unlikely continuities, one lineage that endured fire, famine and ice, long enough to name itself. But survival, stripped of context, is not meaning. What defines us now is not that we lived, but what we choose to do with the life we inherited. The cost of being the last is that there's no one left to compare to, no mirror to warn us, no rival to challenge us. We are both experiment and observer, teacher and student. Our triumph is total and therefore fragile. We have become the architects of an environment that sustains us and endangers us simultaneously. The line between success and self-destruction grows thinner with every discovery, every invention. So what does survival mean when survival is all that's left? Perhaps it's not about outlasting time, but understanding it. Perhaps the real legacy of our species isn't dominance, but awareness, the rare ability to see our place in the continuum of life, to recognize how much was lost for us to exist. When future archaeologists, human or otherwise, unearth the remnants of our age, they will find traces of brilliance and carelessness interwoven, a species that built machines to reach the stars and yet struggled to live within its own limits. They will see a planet reshaped, a story that burned brightly and briefly in the long dusk of deep time. And if they look closely, they will find in our bones and words the same paradox that has always defined us, the will to remember and the fear of being forgotten. Maybe that is what it has always meant to be human, to exist between miracle and mistake, to carry forward the memory of what no longer exists, and to wonder quietly if being the last was ever the goal at all. What if I told you the experiment isn't finished? That after 4 million years of trial and error, fire and silence, extinction and awakening, the test that began with a trembling step on an African plain is still running, right now, through you. The data isn't complete. The story isn't over. We are still the variable, still the question. Every decision, every word, every act of memory adds another line to a sequence that began long before we learned to write. When you look at the night sky, what you're really seeing is memory, ancient light crossing unimaginable distances, the universe remembering itself through physics. But when a human looks up, something different happens. Consciousness reflects that memory back. The cosmos becomes aware of its own story. For the first time, a fragment of matter has learned to narrate its existence. That's what we are. A phenomenon of storytelling written into biology. The universe has learned to describe itself in first person. It's easy to think of our species as an ending, the last survivors of a long evolutionary saga, the culmination of a family tree that began in mud. But science suggests something far more interesting. We are not the pinnacle of anything. We are continuity given language. Evolution doesn't end with us. It moves through us. Every neuron firing in your skull, every memory you preserve, every idea you share is part of an ancient experiment in information, the transformation of experience into persistence. From the first spark struck between stones to the algorithms that carry our voices through time, the mechanism has remained the same, memory-seeking form. When paleontologists trace the rise of Homo sapiens, they describe an arc of adaptation, brain expansion, tool complexity, language, cooperation. But beneath all that runs a subtler thread, awareness. At some point our ancestors began not just to react, but to reflect, to perceive time, to imagine consequence, to fear forgetting. It was that fear that birthed culture, art, writing, and history. Consciousness evolved not just to survive, but to remember, to ensure that something, anything, would continue. In that sense, life's greatest achievement wasn't intelligence, it was continuity. And continuity demands caretakers. Every generation inherits the world from those who left before, and modifies it for those who will come next. But humans added something unprecedented, the ability to inherit meaning. Unlike instincts, which die with the organism, stories persist. They change, recombine, and migrate across minds. In every culture, myths serve as carriers for knowledge, vessels for survival disguised as wonder. They encode lessons about hunger, cooperation, loss, and renewal. Through them, evolution moved from genes to symbols. We became a species whose environment includes memory itself. If you compress the history of life into a single day, consciousness appears in the last seconds before midnight, and yet in that blink, it has transformed the surface of the planet. We've become both the recorders and the recorded, fossils that still think. The challenge, perhaps, is to recognize that this story doesn't belong to us alone. The Earth has been writing for billions of years, in ice cores, in tree rings, in the slow drift of continents. We are simply the first to write back. When you hold a fossil, you're holding a page from that longer narrative, not of humans, but of memory itself. Each imprint is a note in an unbroken symphony of persistence. But where fossils remember in stone, we remember in stories. That may be our greatest adaptation, to take impermanent things, sound, light, breath, and make them endure. Every word spoken, every handprint left, every painting on a cave wall is a continuation of the same instinct that keeps the universe from falling silent. Science reminds us that nothing in nature lasts forever. Not stars, not species, not civilizations. Yet in that impermanence lies a strange kind of immortality. Energy changes form, matter recycles, information once created echoes. When you read ancient words, you resurrect minds that have been gone for millennia. Their atoms scattered, their voices stilled, yet their patterns persist, recomposed in yours. This continuity between memory and matter is what binds us to deep time. It means that even extinction is never absolute. The story remains, waiting for a new consciousness to read it. In this sense, humanity is less a species than a bridge, a way for the universe to carry its own awareness forward. The responsibility that comes with that is immense, because to remember is also to shape. Our tools no longer just reflect nature, they remake it. Our words no longer simply describe reality, they alter it. Every action we take is written into the planet's archive, visible to whoever might study our layer of the geological record. The air, the soil, the ice, all of it now holds our fingerprints. We have become an author whose pen writes in carbon, in plastic, in light. But this is not a warning story. It is a recognition story. To be aware of time is to be part of it consciously, to act as participant, not accident. Scientists speak of deep time as something vast, incomprehensible. Yet every human heartbeat measures it. Every breath contains molecules once exhaled by ancient forests, by dinosaurs, by the first mammals. Time is not distant. It is inside us. The atoms in your bones were forged in dying stars billions of years ago. In that sense, you are not just the reader of the universe's story, you are its sentence, still unfolding. Some philosophers call consciousness the universe waking up. But if that's true, then perhaps the real experiment of Homo sapiens isn't survival, but reflection, to see existence clearly enough to care for it. Evolution has given us empathy as much as intellect, a sense of continuity that reaches beyond our lifetimes. We feel sorrow for extinct creatures we never met. We mourn forests we'll never walk in. That capacity for grief, for compassion across time, might be the rarest adaptation of all. It means that memory has grown a conscience. Every discovery, from the first hearth to the telescope, has expanded that conscience outward. Fire let us imagine community. Language let us imagine minds. Science let us imagine the universe itself. Each step extended awareness, connecting the small to the infinite. When we look at galaxies billions of light years away, we're not escaping Earth. We're witnessing its story in cosmic context. The atoms that built our bodies are the same ones burning in those stars. The difference is that through us, the universe can finally hear itself think. And maybe that's what the long arc of evolution was leading toward. Not domination, not perfection, but awareness, the fragile equilibrium of matter realizing it exists. From that perspective, our role isn't to outlive time, but to understand it. to continue the conversation that began when the first living cell learned to replicate, and to pass it on in whatever form the future allows. When the last of our fossils is dust, when the languages we speak have shifted beyond recognition, the patterns we created, our art, our knowledge, our kindness, will still echo in the systems we changed, in the species we influenced, in the atoms we rearranged. The story we write continues whether or not we remain its authors. In that way, there are no true endings, only handovers. Perhaps that's what consciousness was always for. Not to conquer, but to remember, to testify that life once looked at itself and wondered. To know that the universe is capable of empathy because it once lived inside beings who felt it. Every act of understanding, every moment of curiosity is part of that inheritance. So maybe the real experiment isn't over yet. Maybe Homo sapiens was never meant to be a species at all, but a sentence, an open one, that the cosmos began writing and still hasn't finished. Evolution's last experiment was never about strength or genius. It was about the endurance of story itself, the quiet insistence that meaning can exist, that memory can last, that awareness once sparked refuses to go dark. And somewhere, right now, as you listen, breathing, thinking, remembering, that story continues.